groundwork and lay some rules out. In this presentation, there are no rules. I want this to be a dialogue between us. It's all about learning back and forth. I'm going to convey to you what I've learned over the years about energy efficiency, about moisture control, and so forth, but I'm always eager to know and learn about new concepts and all. How many of you ever heard of Joe Stieber? Anybody read any of his books? Joe Stieber, he has a PhD, he's from Canada. How about John Straub? No? If you ever get a chance to pick up one of their books, you really need to read it, because some of the concepts I'm going to lay out in the beginning of this, the physics and dynamics of constructing waterproof systems, are laid out in the books that they've written. So the fundamentals behind it are pretty sound, and they're both Canadians actually. They dealt with issues up there in the cold weather climates that obviously we don't have to deal with in the way of snow loads and cold weather. With that being said, a little bit about my background. Driving down here yesterday and today, it was pretty nostalgic. I used to frequent this area before I became a home inspector. I worked for Abbott Laboratories for 18 years prior to this, and the company, or the division that I worked for, the diagnostic division, was based out of Irving, Texas. And I was a field rep for them in this area. So I would frequent the Emory University facility, CDC, Eggleston Hospital, it used to be called Henrietta, Eggleston Children's Hospital. And then, of course, there was other accounts that I would frequent also in this area would be the VA and the Camp Medical Center. So a lot of this kind of is, coming down here, it seemed like old home week for me. I did enjoy the work. I didn't enjoy the traffic getting back down here and out. Obviously, like I'm sure you have had to deal with yesterday. So today was an easier ride to come in this place. I left Abbott at the end of 2001, and I wound up retiring with them in good grace. They offered me an exit package, and I took it, and I went on to do something different in my life. So I had to reinvent myself, and the first couple of years of working as a home inspector, I didn't make a whole lot of money, so I endeavored to learn as much as I could. Took a lot of certification classes, stucco, moisture testing, mold remediation, indoor air quality, and the like. So, and a lot of that kind of dovetails into what I've learned and will tell you about today. From the standpoint of the energy efficiency side of things, in 2005 and 6, I think you all can remember this, when the real estate market tanked, we were all looking for work. Not that our incomes went down, but mine dropped considerably, so I had to think, okay, well, what do I want to do at this point? Do I want to continue with home inspections and maybe broaden my service out to do different things? And of course, my wife was always in my ear, well, wait, maybe you want to go back to work doing what you did. I said, that's not going to happen. I'm not going back to work in the corporate world. So I had a gentleman introduce me to an organization here in town called South Base. How many of you ever heard of them? Good. They're still operating a training facility in downtown Atlanta, and I think if you all haven't seen that, you really should go see this building as it is right now. It's a net zero, and if you all understand that concept, they've set up this building, and I'll show you a picture of it here later. they set up this building to not consume any of the utilities resources through solar, through geothermal, but it's really one of the most impressive construction sites I've seen in Georgia. The first concepts that I was taught, back then in the South-based world was we build it tight, we build it right. Now, the building tight part of it was 100%. We're going to tighten up the building envelope. We're going to do things to make the construction process more efficient than what it was. But when you start sealing up a building like this, there's little knowledge of what it does on the physics side of things, because you're eliminating all of the natural energy that comes into a building to dry a building out. So now what do? Well, you can tighten up the building envelope, but it's not without consequences. You have to employ strategies to dry the internal building out, which is by mechanical means. Well, anyway, over the course of time, when I was working with these folks down the South Base, I got HERS trained. I think, Dan, you went to the same class or one of the same classes. I went through the Earlcraft training, became a TA. But in all honesty, there wasn't a whole lot. I didn't see a whole lot of money in it. And as a businessman, you have to think, okay, am I going to invest my time, my resources, and efforts into something that I like doing, but it's not going to make me any money? I've got to really revisit that. So I sort of dropped the HERS certification, let that go by the wayside, and of course Earthcraft now is sort of going by the wayside. There's not a market in it because it's expensive to build efficiency into homes. It's not something that the building community can justify. And the way they construct houses today, everything is done like a factory. You pour the foundation, you construct the sticks of the house, you put a roof on it, windows, doors, finishing products, everything, and then it's off to be sold. So, and they're still doing that today. Now, in the interim, during the time that we were doing work with South Base, Georgia Power came into the scene, and they wanted to get a little bit of the action. They started a program called the EarthSense program, and I got involved with that as a preferred vendor for several years, and then they were trying to create a situation where we were going out to consult with homeowners that had high utility bills. And when you look at this initially in the surface, you have a company that's selling power, but they're wanting people to use less of it. And that didn't make sense in the beginning, but as it went along, it was explained to me that it cost the companies a lot of money to build new energy plants. And it takes a lot of time to go through all the impact studies and all that, just to even get the permits in order to do it. And nobody in Georgia wants one of these plants in their backyard. So they have to fight the social problems and issues that arise to that. So what they were trying to do was to service their customers in such a way where they weren't going to have to increase the production sites in Georgia and in Alabama. So, and the other entity that came into the picture was the Building Performance Institute. They started doing the certifications for the building analysts for them to be able to do blower door and duct leakage testing. So as it stands today, my certification is through BPI. I've done hundreds of blower door tests. I've done hundreds of duct leakage tests, and I know what the numbers look like. I know what the expectations are. And when you start gaining that amount of knowledge, you know what to expect. Every time I do a DET certification on a new construction, I'm anticipating a certain result. Not an exact result, but something within a given window. And we can go over that as we start talking about quality. So, anyway, this is the facility of the South Face. Like I say, this is a facility that mainly deals with training builders, inspectors, contractors alike, HVAC contractors, window installers, and I've seen a lot of folks from those different trades groups go into this facility. But like I say, you can call them and set up a time where they can go in and show you everything around this facility. But like I say, it is pretty incredible. Getting to one of the things that I had to do when I was deciding whether to go ahead and make the capital expenditure of purchasing the equipment, I had to start looking at, well, wait a minute, am I going in the right direction with my business? So I started pulling some statistics down off the website, and I started out with this, and we're currently using, out of the near 100 quadrillion BTUs that's produced in the United States, we're using, the residential area is using about 20%. And as you break that down on the residential side, and these numbers haven't really changed a whole lot. When I ran these numbers back in 2007, the HVAC portion of this was closer to 46%. Now, it's gotten a little bit better because the equipment has gotten more efficient. We've gone from 10 SEER to 13 SEER. We've gone from 80% systems to 90 to 95, 90+% efficiency furnaces. The water heating has kind of remained the same. It was, I think, around 12 or 13%. The lighting was at 10%, 11%, and everything else kind of falls in between. So, in the picture of all of this, you have to wonder, okay, what can be done to reduce energy efficiency? Where's the biggest advantage point in reducing an overall energy footprint on a house? It's the heating and air. So a lot of that kind of dovetails into a different analogy that has been taken up over the years, and quite honestly, 50 years ago, the way it was designed is that we're going to make a building pretty leaky. We're going to ventilate the building. Remember these in the 70s and 80s where these whole house fans were sitting in hallways on the second floor. They were absolutely terrible. I mean, you talk about bringing in all kinds of pollen and particulate loads. I mean, it was a bad idea in the beginning. When I see them in houses, as I go through and inspect houses, the client says, hey, is that working? I said, you don't want it to work. You want to shut it down. You want to close this thing off and do away with it. Take it out. Yes, sir?
I don't want to be argumentative or recalcitrant in any way, but one of the problems I have with slides like this is those numbers that go up there.
Yeah.
I don't recall anybody ever coming to my house and measuring any of my energy consumption.
Right.
Has anybody been to your house? No. So, I mean, is this just your guess?
No, it's a national average. This data was pulled down off the DOE's website.
How do they get it?
From the, well, it's all derived from the Census Bureau, but it's the national average.
How do they get that?
Well, it's all portioned out from consumption. It's basically, they look at appliances, they look at equipment, they look at run load amps, and I'm going to show you a little bit of that here. Just kind of give you a taste of how we calculate it as a building analyst, how I calculate when I'm doing an energy assessment on a house. I have my own spreadsheets that I run when I'm doing this, and I'm looking at current draws off of load panels, and I'll calculate the wattage that I'm using on a specific given appliance, and I'll give it am I using this on a consistent basis, or am I using this on a static basis? And I'll build everything out that way, and it really comes close to this. So these numbers are not that different. Now, you're going to find different circumstances in homes. You're going to see houses that may have plasma screens or LED screens and computers in every room. You're going to see houses that have all kinds of toys, electronics toys that are built into it. You just have to kind of take each circumstance as it comes to you. As an analyst, I can actually put a lot of validity in some of this data. Now, again, like I said, back in 2007, some of it was different, and the biggest difference was the HVAC side. So,
Sandy?
yes, sir.
I know Richard had his hand up over here.
Oh, I'm sorry.
That's okay, but to what Larry's talking about, I mean, obviously, somewhere along the way, there's been a broad-based national evaluation, and us in numbers here represent even smaller microcosm in that regard. But this is electrical, and we recognize that from a heating standpoint, the more common heating element in our region area, probably other areas of the country are significantly different, but we use gas heat.
Correct.
For the most part, and even in the northern portion of the country where they use oil burners and things of that nature, and obviously the efficiency levels are varied in that.
Right.
But this is based upon what is considered just general consumption, and then how the consumption for a particular home is basically divided out. All of those are variable depending upon each of us and temperatures that we set in our own. And we've all inspected houses that we walk into that in the summertime are frigid, and people have the thermostat set below 70 degrees. And there are people who like that. And I mean, so their consumption is significantly greater. And for those who do it like my wife does and sets it 80 degrees, and it's, those factors.
Right. Yeah, well, my wife was going through the change too. She freezes me out.
So, it's a
Her
very,
temperature is 68 degrees.
but I'm interpreting that there are,
Keep in mind that these are averages. This is kind of, this is in the middle of all the scope of data that was pulled from the national averages. And this takes into also consideration, it takes into the fossil fuel consumption.
I see the little logo EIA. What does that represent? Is that just where you go?
It's Energy Institute of America, I think is what it is. And they write trying to remember when I was looking for all this data, because as I was Googling energy consumption, this came up. But they provide data for the DOE, for the Department of Energy. The Department of Energy is kind of the focal point where all this comes into. And their principle behind all of this is to find out what sectors are using energy, where the need is, and they even do it state by state. So I didn't want to distill this all the way down to what we do in Georgia, because I wanted to see what the national averages were, more than anything. So, we all have a specific usage need in our homes, and sometimes, because a lot of it has to do with discipline as well, too. I mean, what do you set the thermostat at? Do you leave your lights on every day? When I was raising 4 kids, 3 of which are girls, my wife and I would be at work, and summertime, we'd roll around, we'd come home, and every light in the house was on. The TVs were going. Back then, we didn't have computers, it was all TVs and radios. My daughters they wouldn't wear their clothes more than once. They would take two baths every day. So when you have that kind of consumption, you say, well, the average mark doesn't apply here. I understand that. But this is a conglomeration of everything that the DOE has accumulated over the years, and this is what we are right now today. This is actually 2015 averages. They're going to come out with another one here probably next year on the averages, and it may be slightly different, but I don't think it's going to be a whole lot different, honestly.
Sandy, I was asking the same questions before, and I had actually built a house for an electrical engineer guru, and I asked him about these kind of numbers. I said, how on earth can they tell what percent of usage goes where? And especially in the electrical industry and the electrical arena, when you have smart meters, I said, can they actually see when your water heater kicks on, when your AC kicks on? He says they can't take that and separate it, but they can see spikes of BTUs for energy consumption that is being used at a certain time, and they can categorize that into a water heater or an AC and separate that. That's how they can come up with something.
Right. There are devices that, like you say, are plugged in for energy use.
The smart meters.
Smart meters, right?
Yeah, they've taken a lot of our products away.
Right.
Georgia Power at one time also, and I'm sure many of us have seen these in houses when we were looking outside and looking at the AC compressors outside, had a control system on there voluntarily applied by the homeowner to regulate the function of the AC system and a cycling process. There were little gray boxes that were there, and it was something that the homeowner could voluntarily have installed in Georgia Power, to my understanding. There may be some others that, Walton and Oglethorpe Electric, et cetera, so down the line, probably use this device, but it was a device to regulate during the cooling season, obviously in the summertime, the frequency of the running of the compressor system and the length of time it ran.
Right.
So temperature and thermostat setting was certainly a driving force, but did not specifically always dictate when it was running. And I'm believing that was the case. Does anybody remember that or say that's not what it was?
He quit saying, and they killed it during the peak time.
Right. Something in that
They
order.
were trying to manage.
Yeah, it's just managed usage. Yeah.
Also, one other thing to drive another point home too is that a lot of these changes you see in this data are also affected by climate conditions. Did we have an unusually hot summer or an unusually cold winter? A lot of the peak months, and I'll tell you, when I was on that preferred vendors list at Georgia Power, I could always anticipate on a cold weather month or a hot weather month, on the 20th of every month, I would start getting phone calls. And this was right at the time when customers were opening up their utilities bills. How much you charge for an assessment? Well, it depends. I want to, what do you have problems with? Well, my energy bills were up over $800 last month or whatever. Well, give me some scenario. Let me know what you're seeing, because every case is different. You're never going to find, as an energy assessment analyst, you're never going to find two situations identical to one another. So there could be equipment issues, and more times than not, we found equipment issues. We also found in older houses, the leakier they were, the more inefficient they were. So my target audience, and I'm going to show you one other slide here too, that kind of comes to mind about why I got into this. Right now, and I ran this study back in 2007, and then of course I ran it last year. I ran it just here not too long ago. In 2007, there was I think the numbers were approaching 127 million housing units in the U.S. And that's everything. That's single family, that's duplex, that's multifamily, that's everything. Pre-manned homes, all of it. So going back over about 100 years, you can see the trail of the construction process and how many homes were built back then. And some of this, obviously, these are And again, it's through attrition in homes that were torn down and rebuilt again and so forth. But the data kind of shows that right now, we're at and above 135 million housing units in the U.S. That's a lot of existing, what I was classifying then, houses that have problems to some degree. So,
One of the main problems is builders are still buying air by the ton.
I'm sorry, what?
Builders are still paying for heat and air by the ton.
Right.
So contractors, example, you buy a 3-ton heat pump air handler, it's gonna cost you $1,300. A 4-ton is gonna cost you $1,400. They're getting $1,900 a ton, whatever. So they can't afford to make the houses tighter, put the correct size system in, so they're putting in larger systems. You know, and even if you work back with 2003, 2004, they were even talking about doing away with flex duct, because flex duct has a lot more resistance. Even today, systems are oversized, ductwork is undersized. If you try to weigh in the charge where it should be, the use will freeze up. So most systems have more refrigerant rather than freeze up. So we've got that 15 series unit probably working like a 12 series unit. But the heat and air contractors have got to do that or you run out of business because it's, you know, they can make their numbers, but your manual changes and recalculations.
Right.
Now you should call that out. I don't have time for that. You know?
Well, no, you don't. And honestly, none of us do. It's, you have to trust the system, and unfortunately today it's sort of failing us.
Yeah, I don't want to hear the ductwork.
Well, here's the problem. I do manual gate counts, okay, and it's time consuming. And on an average house, I have to charge $1,000 to $1,200 to $1,300 to do one. What HVAC contractor or builder do you know is going to buy that for a house? I know that, but I'm going to show you some things where I'm proving that it's not being done at this point.
I asked one just recently that 5-ton, I think, never worked out. And got to me, couldn't give it to me because it's repaired for the outside. You didn't get to the house and said, you walk in the yard and look at the side unit. And the free drywall will go and add to it, and that's not just going to put our better size system.
Yeah. Well, you know the danger in putting a large or oversizing a system in a tight building. You're going to have, that's an easy, if you want to destroy a house, that's an easy way to do it.
All these new houses are the same as square feet they were 20 years ago.
Right, right. Okay. For some of us old geezers out there who were around in the 70s, when I got out of college in 73, I was living in the Baltimore, Washington area. I was commuting back and forth. I was working for another biomedical company out of Beltsville, Maryland, just north of College Park. And I don't know if you all remember standing in gas lines. I was in a few of those, you know, waiting in line for an hour or more to buy a rationed out 10 gallons worth of gas money. And then they had the odd even number of things where you know, and getting to my point about that particular era, that spawned in the building industry a whole new concept of, well, we're going to have to conserve energy. We're going to have to, you know, this was right around the time when they started using thermoglass in windows. They started using more insulation. I'm not familiar with the codes back then on what it was, but I think it was like on the walls, I think it was like R11. But you go into these houses that have never been retrofitted back in that era, and you're going to find what it was like back then. Excuse me. And it's terrible. Anyway, so as I was contemplating on, at the time, buying $5,000 worth of duct washer and duct leakage equipment, I had to look and I said, well, wait a minute, where's my target audience? When you look at where the most houses were built in a short amount of time, nearly 40% of the housing was built between 1950, in a 30-year period near 1980. This was where my target audience is. Because these are where, if houses weren't renovated or upgraded, if you will, they had problems. So one of my first questions when I got a call to do an energy assessment was, when was your house built? Because if it was built back in that era, I said, I think I can help you. And this is what it was all about. Now, most of the houses were built prior to that, it was a no-brainer. The older the house, the more issues you had with leakage, with all different kinds of things that evolved over the years. Indoor air quality was a huge component in all of this as well. You know, the leakier the house, the more contaminated it is. So, another component to the construction industry that a lot of builders and contractors are having to deal with is an issue called stack effect. And how many of you understand this particular issue? Good. Where air rises. So whatever leak sites you have in the lower portion of the building, it gravitates up, and with all the leak sites we have in the upper end of the building, the holes in the sheetrock and the upper floors, all of that airflow leaks in and out of the building. So keep in mind that a building, in its simplest context, is an environmental separator. It's designed to keep the air in and the outside air out. That's what it's designed to do. And unfortunately, with a lot of these older homes, and even today, some of the newer houses that are being built, we're still having this particular problem. And then when you couple that with crawl spaces. The last census I looked at on crawl spaces, we have somewhere around 27 million crawl spaces in this country. And you know what? Most of them are here in the Southeast. And most of them have problems. And every one of them that all of you and I have been in, I can always anticipate I'm going to find something. Mold, water, dead animals, you name it. It's a hostile environment. So when you couple that with drawing air from the outside and picking up all the contaminants from the soil and gravitating that into the house, what's the chance you're going to have problems with indoor air quality in this house? Oh, and by the way, if anybody's interested, this is an excellent way to mine radon. All right. And we're going to move on to the 2009 with amendments. This is what we're currently on today. The 2009 took an extraordinary leap in the energy efficiency world, and they incorporated in it a quality control check. And the quality control check was building envelope and duct leakage testing to verify that all the construction processes met a certain guideline. Today's standards are going to change next year. Let me also say that there's two undeniable truths here. Where the construction processes in the past, we're no longer going to make houses out of 1,000-year-old trees and rocks. It's not going to happen, not to the degree that we're constructing houses today. It's just too expensive. And then secondly, we're never going to go back to the way it was in the energy efficiency approach to the IECC. It's not going to happen. So now that we're using moisture-sensitive products, OSB, composites, laminates, paper-faced gypsum, these are components that you do not want to get wet. So the goal should be, how do we keep the houses dry in an environment where we're constructing tightly built houses? houses that are no longer breathing, that the wet and dry cycle is just almost non-existent anymore. We're going to talk later on about this document. Did we ever copy these? You had mentioned the other day. Okay, everybody's got it, great. Okay.
Did anybody
We don't need them yet. We're gonna go over this toward the end, because I'm gonna show you some things that I've seen on new construction, final inspections that I've seen, and we're gonna go over comparison notes on what you all have seen, because I want to hear basically what you're finding and see if it compares to what I'm seeing. All right, this document is supposed to be completed by the, I don't know what you want to call them, builder, project manager, contractor, supervisor, whatever. It's one and the same. He's responsible for everything that's being put on this document. And they need the name of the individual or the company and their phone number. This contact information is important for the homeowner. Secondly, all the test data needs to be put on these documents. It needs to be clear and concise. It needs to be accurate, and you need to have an identifier. Whoever did the testing needs to put their ID and contact information on this document. Thirdly, all the building envelope design, how much insulation, what type of glazing is on the windows, all of that needs to be incorporated in this. This is important. And then the equipment. The HVAC contractor needs to put all of his information, the type of systems that are installed, the efficiency levels, the sizing of it. And then, of course, they also need to put their names on that as well. And then lastly, which again, getting to your point, we never see, is the load calculations. Now, how many of you out there have ever seen one of these completely filled out?
I have, and I've also noticed that none of them fail.
Oh, really? Yeah. I see that too. I see that too. I'll show you some numbers in here that I just like, wait a minute.
And I'm seeing them pass, but I go up there, there's no sealant,
There's no what?
there's no weather stripping at the attic doors. There's some places no insulation.
Yeah.
And there's
Anybody can fill out a certificate.
pass it.
Yeah. I'll show you some things to open your eyes to. I have maybe 3 or 4 dozen of these. I didn't put them all up here. I've got maybe 8 or 9 of them, but a lot of them are repetitions. It's almost the same thing you see over and over again. Incomplete, inaccurate data, data that looks, wait a minute, how did he come up with this answer? So, all right. Right now, and we're on the cusp of changing this. Next year, January 1, we're going to the 2015 with amendments, IECC. Now, what's that going to do? Well, this basically is a draft of the amendments. This is the cover page. You can download this from the DCA's website and read over it. I skimmed over it, and there are some things in there that say, wow, are they really going to do this? Are they going to put the onus on the builder to do all of this? And I know some of this, the builders may seem somewhat punitive, but there's a reason for a lot of it. But, yes, sir.
The 2015 IECC is the effective date is January 1st, 2020.
That's when they're planning, that's when the DCA is planning to release it. And then this is when they plan to adopt it.
So it's planned for January 1st, 2020.
Correct.
Okay, thank you.
So, that changes a few things on what we're going to see. That's going to, you're going to have a whole new certificate. I'll show you down here in a second. It's going to reduce the air infiltration and duct leakage limitations in a big way. Because as you go through and look at some of your previous findings on some of these certificates, you're going to see, well, wait a minute, they had this number here, it's not going to pass next year. And you sort of wonder, well, are the builders ready for this? Are they going to be ready to, and HVAC contractors, they're going to be ready to deal with this issue when it comes up? I don't know. It kind of worries me a little bit. All right, it's always been about R2 and 3 testing, But here's the major change. And by the way, this is a new certificate that's coming out on these amendments. This is the certificate that we're going to see after January 1. Any house that's permitted after January 1 of next year will have to have this certificate. And it's got some changes in it from the current certificate, so we'll get into that afterwards, after this. But the two major things that I'm seeing that is probably going to change. Number one, I think the R value limitations in the zone 3 is going to go from R30 to 38. That's going to happen. But like I say, the biggest thing is going to be the duct leakage test. It's going from, and the building envelope leakage, it's going from 7 air changes to 5 air changes max. It has to be less than 5 air changes an hour. And the duct leakage, they're doing away with the rough-in testing. You won't, as a matter of fact, there are some jurisdictions that won't allow RIT being done because it's not the final product, and I'm going to show you a couple of reasons why that is. Rough-in testing is basically before the sheetrock is put up. And I've done those before, but after January 1, the state doesn't recognize that testing as part of the quality check.
It's all post-test now?
I'm sorry?
It's all post-test?
It's all PCO or PCT. Okay. The duct leakage testing is huge for me because I tell you, honestly, it's time consuming to do a duct leakage test. Because setting up and tearing down all the equipment, it takes me on the average of an hour and a half to do all of that work. It only takes me 10 minutes to run the test, not even 10 minutes. I can tell you from the first 2 minutes if it's going to pass. Within these leakage guidelines. So, with that being said, I'm going to go through a few of the dynamics, and I'm going to go through the second law of thermodynamics, and I'm going to give you a few of these principles, because going back to what I've learned from reading Joe Stiebert's and John Straub's books, this really kind of rings true for me. We are in an environment where it's almost impossible to build a perfect house. We get hit environmentally, we get hit from all sides. We get hit with cold climates, we get hit with hot, humid. I mean, it's an array of issues. And from that standpoint, it sort of leaves the questions, well, where do you put all of these control layers? Where do you put the vapor barrier, let's say, and the thermal barrier? Where is it best suited? But the principles behind all of this from Joe Stiebert's books are pretty simple. And I'm going to go through this, the simplest form of the second law of thermodynamics here. Heat flows from warm to cold. Can everybody agree to that? Okay. Moisture flows from warm to cold. All right? Moisture flows from more to less. And here's an easy experiment for you to look at. You go back to your house and you touch something cold and you touch something dry. Something dry is wet, right? It's not the something that's wet that's dry. So it's an easy concept to make. Now, the thing that concerns me more about how we're constructing houses is vapor. Vapor pressure flows from high pressure to low pressure. And that's the easy concept to wrestle with. Now, let's say we have a house in Miami. And we're looking at trying to control vapor. If the pressure carries the heat and the moisture, which direction is the moisture traveling from? Is it inside out or outside in? Outside in. Let's say if we have a house in Montreal, cold weather climate, heating conditions in the house, cold conditions outside. Which way does the moisture flow? Inside, out. Exactly. So we get, like I say, we get hit with every bit of that in this in this mixed humid climate of ours. And this is what makes it very difficult, if not impossible, to build a perfect house here in Georgia. We do the best we can. But in some, a lot of times it's not enough. There was a study, actually 2 studies. There was, this study was done, I think, one of the papers I saw was from the University of Wisconsin, and the other one was from a school in Canada. I think it was University of Waterloo. And they looked at vapor transfer, and they're big on this up there because of the fact that their climate is so hostile to buildings. When you take a look at a 4x8 section of gypsum, drywall, and you look at over a course of a heating season, you're going to diffuse a 1/3 of a quart of water through that wall. Now, when you take into consideration, you put a 1-inch square hole in that wall, and you say, okay, well, I've got a leak site right here. Now I've got vapor pressure on the inside of the house is trying to escape to the outside. This is in a cold weather climate now. How much water do you think is going to accumulate over a heating season, or can accumulate over a heating season? Any guesses? Try 30 quarts of water. And the question is, what do you do with it? What happens to that? Well, in a moisture-sensitive component environment, you're going to create some serious problems within the wall cavity. So the goal is to seal the house up. And honestly, the Canadians do it better than anybody else. And people in the cold weather climates here in North America. So what we have to do, and transversely, when you look at warm weather areas, and another study was done, I can't remember the school this was done through, that says that if you go ahead and punch the same size hole into an outside wall, where the vapor transfer goes from outside to in, there's 9 times more water that accumulates over a course of a cooling season. So what happens to that water? As soon as it lands on a cold surface, it's going to do what? Condense. It's going to create water. Now, if by chance it doesn't condense, where does the water go? The simple answer to that is anywhere it wants, until it hits a cold surface. And hopefully that cold surface is our evaporators. Because if it doesn't hit that evaporator, if the systems aren't converting that moist air to dry air while it's cooling or dehumidifying, it's going to cause problems inside the building. All right. Getting back to the wet-dry cycle. And this is an idealized graph, by the way. Don't look at this as a, here's the component, this is the moisture measurement or whatever. I'm just trying to interject a point with what happens when we build a type building. We have a lot of natural energy that comes into a loosely built building, a building that's very leaky. And the dry cycle is pretty easy to discern. When things get wet, the amount of energy that comes into a building in the way of uncontrolled ventilation will create a drying effect. Everything dries out. That's not problematic at this point. But when you're dealing with moisture-sensitive materials like OSB and gypsum and composites and so forth, you can't afford to continue this process, because what happens is on a tight building, as soon as the building gets wet, it takes longer to dry out, if at all. And I can tell you, after 48 hours, if we sustain moisture levels beyond 20% after 48 hours, we're going to have a mold problem. That's just a common fact. And we're going to have, eventually, with these cycles the way they are, we're going to start having a lot of rot issues. And I was talking a little bit to Hank and some of the others this morning and yesterday about this whole thing, and my biggest fear right now is that we're building disposable housing because we don't have this under control. This wet-dry process really needs to be gotten under control. We need to build a tighter building, a leak-proof building. Some of you may say, well, don't we need air to breathe? Well, yes, we do. That's the ash rate 62.2, and I think we're on 2013 now. We're getting ready to go to, first of the year, we're going to go to 2016 guidelines. And that's that we have to bring in ventilation for the occupants. Now, also building a tight building, and getting back to one other, I'm going to get sidetracked here, but building a tight building is where you want to go with this. Because if you take care of the building first, the size of the equipment is going to drop. The capital outlay of the equipment is going to drop. So to me, it makes sense to build a tight building and size down or correctly size your equipment in order to deal with the internal workings of the house, the living space workings. So, yes. Somebody asked a question.
Where is ultimately the point of equilibrium in all this? Because obviously, at a point, you're having to bring in outside air.
Correct.
I mean, we're already seeing that existent now on new constructions where they basically are drawing in through the HVAC system a certain amount of air from the outside that obviously has to be filtered. And the filtration has to do with the environment that we live in and high density populated areas. Because I guess when you get up in the mountains, it really doesn't make a whole lot of difference. Considering that air quality up there is much better than it is.
Sure, absolutely.
But at some point there, I would expect, and I don't know that you necessarily know the specific answer, there's a target here at some point is where we say, this is the best environment that we can create, short of creating a bubble, that we manage everything within that bubble and everything outside is what is outside. I mean, obviously we go in and out of homes that have a direct access to the exterior, and then opening and closing the door of a property, you're bringing in a large amount of air quality conditions and particulate that basically at that point is circulated through the HVAC system and dumped somewhere, whether it's through a filtration system. And the majority of all the filtration systems for HVAC systems today are marginal at best. I mean, we do see some that are what's called high efficiency, which basically is just a higher surface membrane area with a larger, deeper filter and that type of thing. But at a point with all of this coming together, do you know of a target point of where they say, we've come to that? We've come to that level that's consistent?
ASHRAE is moving that target around a lot. Over the years, 2010, they said, well, it's 15 air changes, 15 CFM per bedroom plus one. That's how they, in simplest terms, that's how they gauge it. They dropped it into 2000, when we go next year, they're dropping it down to 7.5 CFM per bedroom plus one. That accounts for one individual in each bedroom, and then the master, there's two people. So that takes care of the occupant load. Now, to your point of how much, I look at it this way, and I've talked to a few of you about this before. We want our houses to have a barometric pressure inside living space, to have a barometric pressure of, the ideal barometric pressure would be 0 with respect to outside. But you always want to kind of lean more toward the positive aspect, because think about this. In our environment, most of our energy use is done to air conditioning. You know, the United States is the only country in the industrialized world that revolves around air conditioning. This is what we design our houses for. But in the South, and in the extreme South, this is what we have to deal with. So all of the vapor pressure that's being applied to a house is being applied from positive to a house that can easily become negative. Think about this. Worst case scenario. Family of 4, get up in the morning, they're taking baths, they're cooking, the laundry may be going, you've got exhaust ventilation fans going. Which way does the house go in barometric pressure with respect to outside? Negative. How do you compensate for that? ASHRAE doesn't even tell you how to compensate for that. They just tell you, we just need this amount of cubic feet per minute per person.
The function in here probably though that I see is that we're trying to compensate for something that we're creating.
Right.
And it's, you know, it's a never-ending battle because we're constantly saying that all of these efficiencies that we're creating within an environment. I mean, I would imagine most of us, just looking at the color of most of the hair around here, grew up in an age area where we didn't have air conditioning in the house. I mean, I was the same way. I mean, I didn't think like the first house that I ever bought didn't have air conditioning in it until I had it installed. And obviously the house wasn't built for that kind of environment. I mean, I guess for a lot of us thinking about this, and this is adding a layer in our inspection process, and fundamentally what we're ultimately relying upon is this one piece of paper and what's printed on here. And obviously what you're talking about here is to kind of help us to understand what all of that comes down to, this one piece of paper.
Exactly. We need to distill it down to that document. And we have to trust that that document is accurate. Even the homeowner has to trust it. If they have problems, I'm representing a client right now, probably going to be deposed on this next month. Lady bought, a couple with 2 children bought a house about 2 blocks from Chastain Park. You know the neighborhood, $2.2 million. House was built in 2015. They asked me to come in and find out why their utilities bills were $1,700 a month. 6,000 plus square foot house. Any of you think that's outrageous?
No, probably not, but that's how it's built.
It depends. I mean, 2 little kids. Honestly, when I first looked at it, I thought, wait a minute, there's something wrong here. You know, why? So as I started looking around the house, I went to look on the load panels and the HVAC systems where that certificate was. It wasn't there. I said, where's your certificate? I said, we've never had one. It was never produced for us. And how many houses have you done finals on where you never found their certificate? More than I care to look at. Yes,
Where are they supposed to be?
either on the load panel, or near the load panel, or panels, or on one of the HVAC systems.
Water heater, I think, is also acceptable too.
I'm sorry?
Water heater.
You can do it. Anywhere. Just
Usually
give me
electric
something
panel.
that I can look at.
In there, it gives you 3 locations, and rarely do you find it at a water heater. Most commonly, it's a low panel.
It is the load panel, exactly. Because that's where the inspector's going to look for it. That's right.
So even if it's there and the municipal inspector takes it with them, it still has to be a copy there.
It has to leave a copy there that belongs to the house.
They'll say, oh, we got it. No, it's got to be posted.
Yes, sir.
Just a comment, having been a member of an outfit called South Face since '95, you know, I don't see many inspectors there, you know, hardly any at all. If you really want to dive into this, as you're well aware, join South Face and go to southface.org. If you want to know more about building science, go to buildingscience.com. And those are the 2 authoritative groups that I would recommend to anyone. And Southface has tons of training classes. So if you really want to know, you can go and study and be a part of this.
Well, they definitely have the market on the training programs in this area. I mean, they're local. Pretty much everybody there is willing to help.
They generated the building code. They generated the Georgia code. Mike Barsick
Right.
and all the staff down there. So they're the leaders.
Yeah. But from the standpoint of the certificate though, I have not been able to find one that I can truly feel comfortable with saying, yep, I see the rest of the house, mechanical structure, how everything is laid out. Yep, this looks good. I can hang it back up and the story. And some of the confounding parts of the inspection process, and I know you've all had to deal with this too, is doing final inspections, is the fact that when you bring this up to the client, it's almost like, I don't know anything about that. So what? Well, they won't know anything about it until such time as they have problems with the house. And then, where do they go? At least they have phone numbers and contact names that they can call to see, wait a minute, why is my house doing this? Do I have any failures and so forth?
You're kind of inferring that the third-party groups that they're supposed to do this aren't really doing their due diligence on their testing and their certification.
Well,
I'm hearing that.
well, what do y'all think?
About a year ago, I was looking at the manual, Jay, load on there, you all seen everything, nowhere close to what was put in there. There's a picture of the nameplates, which includes the system, a picture of their documentation. I said, part of your documentation, you put the wrong side of it. The guy went back 3 times and changed the numbers on that card.
I call it pencil whipping.
Yeah.
Where's that eraser?
So Sandy, what were your results after you went to the houses? What did you find out?
Oh, in this particular case. There were several things. They were having, and I'll show you something else once we get through this part of it. Let me see. All right. Let me show you something that I found on this. This is that house. You know what this is? It's a ducted dehumidifier. And getting to your point about ventilation, there are 2 input ducts on this system. I have one in my house. I love it. Because we have so many no heat, no cool days in this area, you need to have some form of dehumidification. The houses that are going to be built after the 1st of next year will have to have dehumidification. Where does it say that in the code? It doesn't. Because when our latent loads start to increase in houses, and I think Dan, you probably attest to this too, what do you do with that moisture if you don't have dehumidification and you're not running your systems? You gotta have it. Especially how tight we're gonna start building these houses at the 1st of next year. If we don't, we're gonna be in trouble. Anyway, on this particular dehumidifier, as I was looking at it, it's one of the input ducts comes directly from the outside and bringing air in from the outside, like you say. It has a pre-filter in there, a MERV 11 filter on the back end, on the front end of this. This is the input, that's the output side. And another duct, a 6-inch duct, runs from the basement, is planted in the basement area. So we're bringing in, not only are we bringing outside air in, we're also trying to dry the inside air at the same time. We're also doing it through a stage filter and dumping the output back into the return airstream of the main air handler. So it makes a drier conditioned return air, a pre-filtered air, go through the main filtering system.
This requires massive seal.
It requires what, I'm sorry?
Massive seal.
Okay. You got to seal that off. Yes, sir.
Is there any concern when you're doing dehumidification on HVAC about pollutants and stuff with your consumers not changing the filters and so forth?
Yes.
That's why I was told that you should have individual dehumidifiers or recommend that to clients unless you know that they're going to be a problem.
Well, again, getting all back to maintenance, this is most of the failing behind these systems that we see in home inspections. probably better than 95% of the problems I see on mechanics in houses is due to maintenance neglect. And you've got to trust that the homeowner's going to do it. I mean, that's part of home ownership, you know? But you'd be surprised that this gets less attention than anything else in the house.
Question about control of something like this. Because obviously from the dehumidification process, you're setting a level as
Right.
to what the expected humidity level in the house. I mean, you don't want to live in a house with 20% humidity.
No,
That's extremely dry.
it's too dry. In the wintertime, you see those.
But you want it below 60, and preferably, probably, maybe slightly below 50%.
Well, the sweet spot for me is 40 to 50.
So from that standpoint, you're basing upon two factors. You're basing upon what the control element is, and I'm assuming it may be the thermostat that runs the regular HVAC, or may have its own control. I mean, probably would have its own control at some level. And where that control is located in relationship to the placements in the house. Because where one room could be one level, another room could be, or several rooms could be a significantly different level. The microcosm of trying to manage this is becoming beyond what most people, I know everybody's carrying around smartphones now that they can, from the other side of the world, change the temperature of the room.
Yeah.
This is getting beyond that point to where, but my theory, my thought is also, you start pulling in outside air, you're filtering it, and at that point, then you're managing the humidity through the device.
Right.
Who basically is nothing but a small AC unit.
That's exactly right. That's what it is. A dehumidifier is an air conditioner in reverse.
Right, it's the same thing.
Yeah.
So, this is,
To your point, in this particular instance, this system is hooked up to a remote humidistat down the hallway from this location. This is a utility room. When I got in the basement, I was hearing the hum of what I thought was this being running. It was running the entire time that I was there. The whole 4 hours, the first 4 hours I was there, it was constantly running. And I looked at the humidistat, and the set point was at 50% RH. But the reading in the basement was 38%. Something was wrong. What's wrong with this picture? Why is this thing running all the time? And again, to your point on energy use, and by the way, when all of you are looking at these systems and portables or whatever, if it's not dumping, if it's running and not dumping out warm air, it's not working. If it's dumping cold air, that condenser inside that unit is not working. Now, portables, from my experience, have a typical life of about 3 years. You can go to Home Depot or Lowe's and buy one of these and put it in your basement and almost anticipate in 3 years it's not going to work anymore. They're disposables. This, on the other hand, is a little bit more robust. You're going to get a little bit more use out of it and longevity out of it, but you've got to set it up right. So, as I was doing the analysis on this, I'm thinking, man, this is running all the time. Has this been running 24/7 over the course of the time this owner has had this house? And this is all installed equipment when the house was built. This wasn't an afterthought. So at least the HVAC contractor had enough foresight to put this in. Now, I went on to the label plate. And I looked at it, so, man, how much power is this thing consuming? Well, the RLA on this says it's running at 7.4 amps. So if you take and run the math 24/7, and you can look at this, and it's every month, it's adding $76 and change to your utilities bill. That's just one component of all of this. So, in setting on mine, I have a similar system as this. I have an Ultra Air, I have a B100 that I have coupled almost right up against the return plenum of my main unit, and the duct system is laid out pretty much the same as this one. My humidistat in the basement is set to 50%. I also have it coupled with the relay on the air handler's blower unit. So whenever it's running, the blower unit's running. And I have it set for I had it originally set for every 20 minutes to turn itself on for 5 minutes to cycle fresh air into the house. You know, a lot of this is design work. It's not, you know, some of the HVAC contractors are just getting into starting to know about this type of stuff. I know I've got a handful of contractors that I trust implicitly that know how this stuff all works and know how to set it up. But to the point of concern about manual J's and things that have to do with design, designing equipment, everything is going to have to change because we're building tighter buildings, and we're going to continue to build tighter buildings. All right. Moving along here, how do we build energy efficiency into residential construction and control the moisture levels? Well, there's 4 independent looks at this that kind of come into play. Number 1, design. Now, as far as the building envelope, that comes first. It's never equipment first and house second. You have to design the building to accommodate whatever you're going to utilize and install as far as the mechanics go to control the living space conditions. And that comes with knowing where your thermal barriers are going to be located, your vapor barriers, and so forth, and all of that. Do we have this laptop plugged in?
What was the question?
I got a battery low condition on this laptop. I didn't know if it was displayed. I had to look.
I'll check.
Okay. All right. Secondly is mechanicals. Manual J, Manual S, Manual D. Now the code says Manual J is required. And in some aspects, in the 2000, when we go on to 2015, it's going to specifically say Manual D. You cannot get to Manual J, you cannot get to Manual D from Manual J. You have to go through Manual S. Does anybody here know what Manual S is? It's equipment selection. First, you calculate the load characteristics of the building. Heating and cooling. How many BTUs do we need to keep it cool? How many BTUs do we need to keep it heated and comfortable? Then the next part of this is selecting the equipment. Now, RightSoft has a list of, and I download this periodically as I'm doing these. It updates itself. I don't know. And that, to me, takes a lot of time because it's not a one-size-fits-all. A 4-ton system from Carrier may not be the same as a 4-ton system on Train or Lennox or Amana because of the airflow index. You've got to balance everything out. The CFM on the blower, how you can select and make sure that your airflow is going to be balanced out with the size evaporator you're going to use, the size of the heat exchanger. All of that has to be taken into consideration. And then you can get the manual D. Then when you know what your CFM output of the system is, then you can design a duct system that will distribute it evenly throughout an entire house and not have cold spots and hot spots. And is that a perfect scenario? Nope. It's never a perfect scenario. Because I find times where if I'm going behind a contractor who's telling me, man, I've got a problem, I've got a complaint with a client who says this portion of the house is hot or cold. I have to bring my flow hood out and go ahead and check and see if all the CFM is correct according to the design. Now, does that happen all the time? Not even nearly all the time. It's just thrown together, put in place, and it's done. You know, the days of, you know what the manual J used to be? Probably being a little facetious about this. How there's a joke in the mechanical industry that, you know, here's my manual J. They use the finger method. You ever hear that? HVAC contractor will walk out to the street and look at a house and say, let me see, 5 tons, 4 tons. I think a 3-ton will do it. That's how they select it. It goes into a house. You can no longer do that.
You can't do that, because you look at a new subdivision, all those houses are basically the same, all dug were the same, but they face different directions.
Yeah, you can, load calculations taken into consider all of that.
Yeah.
Orientation. You know, because a lot of the spec-built and tract-built houses are not identical to one another. And there's no, and I can tell you this from experience, there's no manual J that I've ever done that's been identical to another. It just doesn't happen. If it is, and I'm going to show you an example of one in some of these sheets that I'm going to pull up, that I kind of looked at it and I thought, oh my God, you know, this is the same contractor who did this. So, anyway. All right. The next part of the implementation of energy efficiency is implementation. And this all falls back on the builder, the contractor, again, like if you will, manager, whatever. It's his job to make sure that the trades and the subcontractors are doing their job and doing it right. Because if they don't, none of this works. So from design to implementation. Now, from the standpoint of installation, we're working with decent products. We continue to work with decent products. It just is that we're working with moisture-sensitive materials. So, getting back to the implementation process, you have a builder who gets ready to start construction, and he gets dumped on from suppliers all those components, all these materials in the front yard. He says, okay, now we're going to put all this together. How do we do it? There's an orientation that has to be followed. There's processes and everything that have to be controlled. And if you don't get that in check, again, all of this falls apart. The wheels fall off of it. So workmanship around building envelope is extremely important. And have any of you seen John's, John had a, what was your, where's John? He had a seminar last year at one of our meetings that I thought was excellent. And it had to do with waterproofing a house. And it showed some of the dynamics of where the flashings needed to be and how to incorporate the air sealing process and all that. That was a jam up. Kudos to John. And then, of course, on the mechanical side, you know, you want the HVAC contractors to do their job, and that's to install the equipment correctly, according to the design. Now, is any of this checked by the contractor? Not very often. I don't see it happening. Not unless there's something blatant, like, hey, wait a minute, that duct's not connected. Or this system is not in position correctly. It's the simple, easy things to see that are caught by folks like, you know, who are involved in the project. It's up to us to call out what these issues are. And I know this kind of sounds like I'm making your jobs complicated, but our eyes are our best tool. And understanding all of this is going to make our jobs much more complex, I know, but it's also going to give our clients a better product. And that is an inspection process that they can truly believe. Yes, sir.
is it now in effect, or is it proposed, I heard it's now in effect that the trades, particularly HVAC contractors, liability entails now. So you're saying you're in a court case. I'm assuming if you find a defect within the building, it's now the HVAC contractors, they're required to do this.
Correct.
And liability entails. Correct?
See, you have to understand that the builder or the contractor who built the house is also culpable.
So they're both culpable then.
Exactly. In this particular case I'm working with right now, on this client down at Chastain,
They're suing the builder.
and the HVAC contractor are being deposed as well.
So as a private inspector, I've told that to clients. I said, I'm looking at the system. I'm not doing all the load calcs and I'm not measuring the volume of the space, but the builder and the contractors, they have the final responsibility that this is done, the legal responsibility.
Correct.
Is that in effect now?
Yep. Well, here's the state requirement. The state says that builders shall build a house according to the minimum standards. I don't care what the local jurisdictions indicate. If it passed, they gave a CO or whatever, the story doesn't end there. It's, at a state level, there is responsibility laid on the builder and the HVAC contractor's shoulder. But, a lot of that gets diluted down with, well, he said, she said, and all this, and this whole case is very complex, and I won't get into a lot of it, but there's more things behind the scenes than this. This client of mine, who has more money than I do, they've already spent $106,000 in legal fees on this project. They want out of the house. They want the builder to buy the house back. A house that was built in 2015. I was telling, and the attorney even interjected this when I had a phone call with him a few weeks back, that's not going to happen. It'll never happen. Because in the state of Georgia, it's buyer beware. So, and here we are. And what I'm fearing also too, with what I'm sampling in all this legal issues, is that this is going to get even more of a problem for individual homeowners. That they're going to see these systems fail and there's not going to be, well, what recourse do they have? Spend a lot of money for legal fees, go after the builder, HVAC contractor, whoever they felt did them wrong. It's a tough decision for homeowners to make. It really is. All right, getting to the trades, and I see this a lot. This is one of my earlier home inspections where they said, hey, the house is ready for pre-drywall. Oh, really? Okay, let's go and look. This was a picture I took above a garage living space level. The guys who put in plumbing and electrical, mechanicals, they have a tough enough job to deal with, well, wait a minute, how am I supposed to route this pipe or this duct through this area when they only give me so much space and everything else is in the way? But at the very least, they can tell the other tradespeople, hey, wait a minute, I had to run this pipe, or I had to run this duct through this area here. I cut one of your pipes in order to get it through. I just want to let you know that. That would be the considerate thing to do. I know you've seen some of this too. All right. And then lastly is quality assurance. We go into, and a lot of you who have done pre-drywall inspections. How many of you have gone into pre-drywall inspections and it has not been ready for insulation and drywall? Yeah, plenty of times. I've had to reinforce the issue when I have a pre-drywall client call me and says, I've got a pre-drywall, and I'm doing one this coming Wednesday, and I've already had this discussion with this client. in an over 55 community in Woodstock, which I'm seeing a lot of, and I think a lot of you have probably seen these over 55 subdivisions go up. And this one here is the 7th house I've looked at in this subdivision. And all these folks who are retirees and everything, they're going to the same church, which is kind of nice because then there's a runoff on referrals that happens through all of that. But anyway, this particular client is, I had this discussion with him, and he said, I need you, and this was like a month and a half ago. I said, hey, I need you to do a pre-drywall and final inspection for me. I heard you do good work, blah, blah, blah. Okay, all right. When is this going to happen? Well, it's going to happen sometime in April. I'm not sure exactly when. I said, well, here's what I need you to do. I need you to go to the builder's agent, and preferably to the builder, and let them know what your definition is of pre-drywall ready. So we don't have any problems with incomplete processes. All mechanicals, electricals, low voltage, plumbing, and air sealing needs to be done. That to me is the definition of pre-drywall ready, before you cover things up. None of that's being done. And I'll show you some photos here in a second. What concerns me is that, okay, well, I'll get it done. And you start seeing so many of these leak sites that are in the building that are looking, oh my God, did they know about this? Is this something that they missed? Are they going to take care of this? Nobody goes in afterwards to take a look at this. Does the municipality look at all of this? Can you guarantee that? We spend more time, and again, to Michael's point, I'm not damning the jurisdiction community at all. They have a tough enough job going out to do 15, 20 inspections in one day, and they have so much time to take a look at things. But I spend, on average, 3 to 4 hours doing pre-drywalls. I can't get it done in any certain day. What's the chance a jurisdiction inspector is going to look at all of this? None. No chance at all. I think there's a market in here for us, to be honest with you. If they can't do it, why don't we do it? Why don't we set up a program where we can go to the jurisdiction and say, we can do your air sealing inspections for you. We'll spend the time here and do them. I don't know how much money is into that, but I don't know. Gas money maybe. Yes, sir.
I did pre-drywall a few weeks ago. You all get the sticker on windows and off display instructions. And this window said, don't use expandable spray and foam products around windows. It tells you blue spill, lead spray foam. I don't know if this is true. The builder came and said, the county inspector said, I've got to use. I said, he can't tell you do not follow this installation instructions.
Correct. Well, the reason being is that you don't want to use expandable spray foam is because it's a closed cell product, in essence. When it expands, what it'll do is it'll compress that joint.
Yeah, I know idea, but I mean, the builders, I think I do a lot of pre-drywall and do home inspections. It's almost a waste of money for the customer because the builder has to fix anything. People are mostly involved buying these houses. They just buy them as is, but at least they kind of know what's wrong with it.
Right.
I've never had a builder.
Well, on the can it says, for windows, don't use for windows.
Yeah. And the little sticker said, I always put in my report, this is what the sticker says.
Yep. Yeah, oh, I know it. The windows are the worst leak sites, and I'll get to that here in a second. Windows are the worst leak sites for buildings because they're not installed correctly. And you have a window manufacturer who says, here's my installation instructions. You level it, you secure it this way, and here's how you flash it. Put your vapor wrap on. Well, how do you do that? A lot of the statements are done by others. Well, who are the others? There's quite a few others out there. Do they all have the same processes? No. And honestly, you can't trust that a lot of the uniformity in installation is going to keep up with that. So, did I lose the screen? Oh, no. It did. Well. Sorry about that. I'm not sure exactly where it was.
We'll call that the blue screen of death, right?
Yeah. Yeah.
What do you know about the architecture of the house inside, the design, as it relates to energy? I'll give you one example. I did a brand new house last week on Indian Drive. And the thermostat is right there downstairs, and 35 degrees. The thermostat in the master bedroom set at 55 degrees. 84 degrees in the hallway upstairs. The scaffold goes to the supply duct for the break room, which were operated by the thermostat downstairs, with a complete two-story flight.
In the hallway.
They were heating.
In the hallway?
Yeah, well, it's older home, right?
Right.
And as I told the builder, I said, I mean, you've got to be able to control the temperature. He said, that's what that temperature is. I said, only thing I can do is just put it back on HVAC. They need either some thermostatic damper somewhere, move the thermostat, maybe out of the white room, you know, but
Yeah.
that's never going to reach that temperature.
They had something in mind about that in order to try to control that temperature variance in those locations. One of the fixes, and I've actually done this more than once, on one of my assessments, in order to control that or try to reduce the variance in temperature between one zone and another, is that you place returns in strategic locations, not supplies, but returns, because typically the duct system is undersized. So the first thing you're going to do is, well, wait a minute, we need more return. And the question is, where do you put it? In your case, I probably would have put it in the hallway staircase, a return, a 10-inch vent. And then you can hook it in, because then with all that warm air traveling up, it'll suction all that back to the main air handler. And then you've got at least, you're not going to get it 100%, but you're going to reduce that variance to a degree where it becomes a little more comfortable. That really, all of that goes back to design and the lack thereof.
It's hard as an inspector, because it's not my job to look at that kind of stuff. The design of the, as far as the distribution system and that, other than the garages.
Right.
But if we have to tell the guy that's buying a house, you're not going to be happy. There's no way you're going to be happy.
Right. How many of y'all have gone into a house where the HVAC is running and you can hear it? Oh, you know what that's from?
Usually the fence.
Too much static pressure because of undersized ducts.
I took that course on myself in 15 years.
On the code, you don't look at the requirements for return everything.
Yeah.
Use the size of return to the supply.
Exactly. Well, let me ask you this. We have, are we on a break or something right now, or?
Yeah,
I've got, absolutely.
So, let's just say, we'll come back here at 10 to, no, 20, let's just say, it's supposed to take 20 minutes, hopefully they'll, let's just say 10 o'clock. Everybody take care of your nature break, make your phone calls you can do, hopefully we'll have this back Here it is.
But no, I don't. Home gate, I probably use about 1% of my gas. I mean, some days, I don't want to say something about a basement house, a slab house, you know? So I just talk about and I may get some too generic. Okay, let's talk about this. And they give us some extra. Basketball court.
Well, I assume it's all going to work out.
Yes.
Basketball.
No.
Good to hear.
It's like, you know, sort of like at an angle.
Step down.
Step down. A full basketball.
Yeah, I've inspected some of those bad boys. Brandon did one out in Kennesaw, and my client, he loves this Spanish architecture. And it's 11,000 square feet. It's on about 35 acres of land. Not Kennesaw, and so I'm inspecting the house, and he's there. I'd already spent money for his office about a year ago. He didn't buy it because the inspector came in and he told me what it is. Anyway, so what he said, what he was doing is, he got involved in husband about 2 months ago. She wants us to clean up the yard. He said, whatever you want. Matter of fact, we were there putting a radar set in. There was water standing in the basement shower stall like this. It's like a 800 feet. There's just under 1,000 feet of the road. He said, I want to price it cost about $200,000. No problem. Anyway, so when I'm there, they're talking about this thing. And it turns out that Savannah and we're all kind of like in Hollywood. You know, all the films and stuff. They came into the original owner, him before he died. And said, we'd like to come in and rent your house 3 months for episodes of The Walking Dead. And he said, I don't believe it. So I'm not going to be. I want to pay him $150,000.
And the man says, no, I don't believe it.
So my client said, I was looking at the said, well, can we just bring all the zombies you want over here? He said, I've got a house up in Asheville, I'll go stay there for 3 months.
What did you do?
Hey, buddy.
She hit a client.
And they hit me back.
Didn't want to pay her.
This is Candy Coast, guys. This is in November. And this is just a little creek over by our house, you know. Was it Coy? Well, look at this car. That's how Coy started. See the dark fish? That's a color. Really? Genetics.
I'm always worried how light she is. I mean, I go up on it and it says 250, 225 max.
He's maxing them out.
See how they work the trees up.
Oh, yeah.
All those people.
Well, that's pretty cool.
Oh, it's absolutely worth it.
and people come from all over the world.
So they actually don't want these to fall, so they,
Because of the
the land, all the well, this is have you ever heard of the Angel Oak? It's in Beaufort, South Carolina. The thing is,
they do it at night.
it's a thing's about 1,000 years old. And it was in Christie's family back when she was just a glean. And we went out there to see this thing, and they do something similar to this, but when these branches come all the way down and touch the ground, they're all propping them up, strapping them up, and you come to see this tree from all over the world.
That's the answer to the question, how do you store 26 cars in a space for 4? That is a parking garage, right? So it's just a frame with an elevator in the middle.
What if I went out there?
All right, get in here, we're gonna draw the first number.
It's hanging out at this thing.
Go ahead, we're gonna.
You know, they got, and then this is a great picture.
092.
What?
Picture Godzilla. We got Godzilla hanging over. That's in there you go.
We win.
Let's go to another number.
Last 3 digits. 070.
Get off of those zeros.
Go with the zero.
No.
And what? What was it? 070? 070.
Last, is that the last 3?
Last 3.
I got it.
Hey, bravo.
You got it? You got it.
Save my bell.
Is these old fast, beautiful old fast
Where they went off.
It's where they were not, the wrong part of the country, and it's part of
So your nephew, pretty bad.
and it's just.
Home gauge is working their way down.
Oh, I'm sorry. Yeah, I'm one of the few that actually signed out.
All right, let me make a quick announcement. We, over the past number of years, we have been donating to an organization. We have been giving back to the community when we can. This year, we are donating $750 again to the Shepherd Spinal Clinic. They could not make it here to present them the check, so one of us will go down there and present it to them sometime this week or next. So that is for the Shepherd Spinal Clinic, and you just never know when someone might actually need that. So we're acknowledging them and their hospital, their clinic there. So we have Home Gauge here to talk to us a little bit about what they can do for us. Take it away.
How's everybody doing? Good. I'm Susie. I was here a couple years ago. I see some familiar faces, meeting some great people. I work for software sales and tech support. So come talk to me if you want to learn about Home Gauge software, our services. We've got a new version coming out. I'd be happy to tell you all the exciting things about that. We're also giving away 360 camera. So come by and hear more about us, and we'll put your card in the drawing.
My name is H. I work on the website part of Home Gauge. We are actually equal opportunity website builders. Doesn't matter what software you're using. If you are using HomeGage, we do have some tools that can integrate with your website. We are doing a show special for just the attendees of this show for $100 off the website. And $100 off the software as well. $200 off the complete package, which includes the website and software. So you can just give us a call, mention this show, and we'll take it from there.
Hi, I'm Jenny. I am our extra care team specialist, and if you are a HomeGage user and you are signed up for extra care, I have t-shirts for you out there. If you are not signed up, you can sign up today and get a t-shirt. The extra care program is simply a way for you to help make your life, or the buyer's life a little bit simpler. They can use aspects of the report for their home insurance quote rather than trying to sort through all the paperwork and find the information. We do specialized training for the insurance agents that are part of the program and connect them with the buyers if the buyers choose to opt in with that program. And we have a new E&O insurance as well. It is a pay per go as you go per report and starts at $270 for the first 25 and goes as low as $7 per report. And that's underwritten by Lloyd's of London. So if you have any questions about those programs, you can come on over to the table and we have all the information for you.
And then for this show, I'm just going to demonstrate the 360 camera real quick. So everybody put on your best photo smile. And bear with me one second. I'm going to upload it to our Facebook page, so you have to check that out. All right.
Alright, this does work with an app, but I don't have it on my phone. But it does work really well with an app, but you can just press the button. So everybody, 1, 2, 3, say Yahi! All right, cool. Thank you so much for having us.
All right, thank you. For those of us technically challenged, what is a 360 camera?
So this camera, it has 2 fisheye lenses on either side, but it patches the image together. So when it's uploaded to a HomeGage report, your buyer can look up, around, high, low, all over a room or an attic space or a roof. And so they get a really nice spatial awareness of everything. You can put it in your report. If you choose to not put it in your report, you can also use it for liability, so you don't have so many just-in-case photos to take up memory on your computer. It's just a JPEG, so it doesn't take up as much room as like a video or anything like that. So instead of having a bunch of pictures, you can just do one in each room, and it literally just takes one click, and then you got it.
So does that, I'm not sure I follow, but is that just, you take a picture and you can look at it on a printout, or is that something like Google where you have to move the mouse around and you can see?
Yeah, so it's 360, so you move the screen around.
You move the screen, that's
yeah,
neat.
not printed,
Right.
but a lot of things. Yeah, a lot of things like Google. You have Google Street View. A lot of.
And that's an app you can put on your phone?
You can. This is the Ricoh Theta camera. It goes for $170, but we are giving away a couple during this time here, so enter your card in to win.
Did you use the phone or you can't use that?
You can use it. Yeah, you can use it. It doesn't like go into the companion app, but it's not very hard to just load it up separately, through the software and just add them. Most people do that anyways, because the companion it would take an extra step. It's easier just to kind of bulk add them to your report, either in a 360 section or an overview or something like that. If you're wondering how to get it into your report and what's kind of the best way, I'm happy to show you what some other people who are really, using it and people are loving it, what they've done and how to make your report kind of have those sections available.
Okay, thank you, HomeGage.
All right. Before I continue with this, I want to finish up on a point that somebody brought up about temperature variances. I think it was one of these inspectors over here, but in the question I was asking, how many of you ever heard a system running in a house? When you first walk into a house, you hear that low roar or whatever. HVAC systems are designed to work off a low static pressure. Less than half an inch water column. Most systems are designed that way. The reason being is to conserve energy, is to utilize energy in the most efficient way possible. Now, single speed systems, they're either turned off or they're ramped up. If they're turned on and when they come on, they're running at a single speed and they develop so much air pressure. Now, if your duct system is not designed correctly, if it's undersized, or if you have ducts that are either pinched or not. I went into a house, here's an example. Went into a brand new house in Ackworth. This is probably back in 09, 10 time frame. As soon as I turn the system on, I hear this roar. It's like, what the heck is that? Single unit house. And I was looking around and said, what's causing this problem? And what it was, there was a return duct that had not been cut through a sheetrock. Anybody ever seen that? Yes. I would think that there's probably more of those instances that are going on right now that we haven't discovered yet.
When you take the access panel off when the thing is running, you take it off in terms of these two, bottom down, before it turns the bottom off, there you go.
Yeah. It's like, well, you know what that does. When you run the system that high with static pressure, you're going to shorten the life of the equipment.
You take a little piece of tape and take
the interlock switch, right?
And then take the door and then get close to it. It sucks it out of your hand. You know you've got it.
Yeah.
Like some of that stuff is going to for the earthquake 15 years ago. We were talking about that, the return, and how important it is for a system to function properly. And the question came up is that how many people have seen the little, someone say, well, it's that gap under the bedroom door. They did calculation, that gap would have to be 14 inches. And I cut the whole bottom of the door off to make that work properly.
Well, you know what, on existing houses, when I look at them, I look at something similar to that, but I look at the dust trail around the cover. You see a lot of dust accumulation around the cover. You know that thing's starving for air. That air handler is so drastically reduced in airflow that, and the other part of this too is that increases your energy footprint. Because the system is having to work longer in order to condition the air. Your on-cycle times are consuming energy unnecessarily because of the ductwork. Ductwork is half the battle to get these systems right. If you don't have the duct systems right, it doesn't matter what piece of equipment you install. You can install the most efficient, you can go from 13 SEER, 14 SEER to 21 SEER, and you're still going to have the same result. So upsizing, downsizing, if you're considering on doing that, or if you know anybody that's doing that, you need to be cautious about that. Because if your ducts are not sized correctly to the size of the air handler, you're going to wind up hurting yourself with it. So, okay. Let's move on here. And then getting to the final part of this is the blower door is testing. Again, like I say, this IECC is not, you're never going to see this go away. If anything, you're going to see it go tighter. You know what the Canadians' building envelope leakage requirements are? 3 air changes an hour. Imagine what they have to do to buildings to tighten them up. And it's a necessity of a net cold environment. Here's one of the pictures I took of a house, I think it was last year. What do you see wrong with this picture? This is a second floor, 2-level attic. What's the purpose? Where's the blocks? There's no blocks. There's no blocks in this. Knee wall is what you call it. This is what it's supposed to look like. Here's another thing. If you look in the back of the amendments, 2009, or actually 2011 amendments, you're going to find all of these CAD drawings back there. You're going to find every one of them. This is also in the 2015 amendments that you're going to see next year. Now, what happens to all of this, and here's the rub on all of this, okay, you don't have blocks in here. You've got conductors going through walls. When that airflow drafts downward or drafts upward, it's a leak site. This house was pre-drywall already, is what I was told when I came to it. Now, this is this is not a new one, this is a site that I did an energy assessment on back probably close to 10 years ago when I was looking for leak sites. And as I was running thermal scans to this, you can see the signatures where the airflow goes up. It's coming up in between the sheetrock and the top plate, and it's also coming up from the unsealed openings. Now, we're required to do draft stopping on all of this, so more than likely, if this was done today, this would be, you wouldn't see this signature through the conductor openings. You'd probably see a little bit from the contact surfaces around the gypsum and the tube eyes. But it's pretty evident that, this is just an example, but imagine all the partition walls that are in a big house. And this is just a representation of all of this. So, again, air sealing is really important when it comes to this type of construction. How about behind bathtubs on exterior walls? We're supposed to seal those off. If you don't find any air sealing behind those, that's a defect.
Also cold eyes.
Yeah. Imagine stepping in a tub on a cold winter morning and all of a sudden you think, oh my God, man, I feel like I'm outside without this. How's an installer supposed to put insulation and a thermal barrier in between these wall cabinets and get it in effectively? Here's one that was done, but you still don't see it sealed at the floor. You're still going to have airflow coming in between those cavities because it hasn't been sealed. Here's a better situation, but it's not right. They put this sheet wood barrier up. They sealed it all the way around, but they never extended it up through the platform where the tub sits. That's what's supposed to happen. You won't see too much of this anymore. This is how about garage ceilings between attached garages, between garage walls and living spaces? Where do you think you need the sealants there? Between the joists. It needs to be sealed up. When I go into, and this is another example of what I don't see during pre-drywall inspections. How am I supposed to say everything looks okay? Do I say it's a defect, or is this an oversight, or is this going to be taken care of? I mean, there's all these questions that come into mind about all of this stuff. Front porch. This is all the joists that are running over the overhang of the front.
Now, if you're going to do the foam insulation.
I'm sorry?
If you do the spray and foam insulation, then all that is supposed to take care of that, correct?
Well, it's supposed to, if it's done right. And I'm going to show you an example of one that wasn't done right. And I'll give you an example of that. Now, this one here, I took this on the same inspection process. You can see the guy down there. They spray foamed this while I was there. So, in essence, during this inspection, the guys were there trying to finish up some things. But again, getting back to, is this really pre-drywall ready? And it's not. And it's kind of frustrating because I'm not delivering the product to my client that I want to deliver to them. Where I can say, yep, everything looks like it's sealed up right. They can proceed. Situation that happened over in Tucker just this past year. Client who's building a house, you see the vapor wrap that's up. Again, the same type of scenario where these beams were actually placed on top of the exterior wall jacks. And of course, you have these gaps in between here that you've got to see a lot. And these are locations that are important because this is where the Achilles heel is on holes in wall cavities. You know, when you look at this and from the inside, you can see this picture. I'll show you justice. See that little opening right up here? Like this little spot right there? Look at that. They found it.
So you're going to redraw after the wall insulation?
No, it's pre-installation. But see, a lot of the contractors say,
Contractor, I'm putting in sealing all the holes and stuff, the installation contractor does that.
that's exactly right. That's exactly what I'm hearing from builders. Is that, oh, don't worry about that, my installation back. Wait a minute. How am I know it's going to be done and how am I know it's going to be done right?
Yeah, I always
Yeah. So, there's little subtleties that I mean, maybe it's just my genetic defect, but I start looking at these things as what if scenarios. What if it was my house and I was looking at this and I would say, wait a minute, time out, guys. You got to take care of this. But your average home buyer isn't going to know this. So, you know, I used to play a lot of poker when I was in college, and you know, it's the old saying is trust but verify. Well, there's always, so the guys that let the dealer cut the cards. I want to make sure that everything has been verified. So, yeah, well, when everything is done, then what do you do if the blower door fails because of this stuff?
I mean, I've been in the pre-drywall and the building already put the drywall up.
Yes, sir.
I have an answer to that question. And the answer is you fiddle around with the numbers on the COC to make it work out, right?
Oh, yeah. 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 And it's unfortunate, it really is. It's just, it's not it doesn't leave me with a whole world of confidence, to be honest with you. All right, next part of this. Again, getting back to Joe Stevert and John Straub, they've written some, like I say, some good books. I think you ought to pick up one of these guys' books and read through it. It's a simple read. Joe's book that I've read is about that thick, and it's kind of a Reader's Digest version of his interpretation of how to construct tightly built houses to control moisture. And I'm going to steal a little bit of his information from his book here to just kind of give you an idea on how a wall should be built. A wall that we can use anywhere around the world. And it's based on an order of format. Where do you place your thermal barrier? Where do you place your rain control? Where do you place your vapor wrap? Where do you place your air barrier? And too many times, because everybody has their own definition of where it should be replaced. I don't mean you all, I mean contractors. This is where a lot of it gets convoluted, mixed up. And this is the reason for a lot of the failures we're seeing in houses. I would venture to say, from the last 5 years, if we were to go in and do a post-mortem on any of these recently constructed houses, we're going to find a lot of wood rot and mold. That's almost a given. So, with that being said, I'm going to probably have to fast forward this, and then we'll get to the nuts and bolts of this. I don't want to get too far ahead of myself. What time are we breaking for lunch? 12, okay. All right. Construction. There's a water control layer. Talking about something very simplistic now. There's an air control layer. Where you place these is very important. They need to be placed on the outermost portion of an exterior wall. A lot of times, these layers are one and the same. Tieback is a perfect example. It's a water control boundary, it's a vapor control boundary. But when you look at the most important aspects of a wall, the two most important things, and by far, the rain and water control barrier is the most important aspect of a wall. And comes second is the air control barrier. We can make a wall, we can make a building work by these two features alone. Now, without a thermal barrier, obviously, in most extreme weather conditions, our heating loads would be ridiculous. But to control an environment on the inside of the house and protect it from moisture harm, these are the two most important aspects of it. Vapor control, again, getting back to where we are right now, we have a situation where, because we're getting hit from all sides, we're getting hit with cold environment, hot, humid, and so forth. So this is where the design aspect of it is extremely important. The vapor control layer, again, like I say, can be one and the same, and it is not as important as the first two, nowhere near as important. You can make, like I said, you can make a building operate with just the first two control layers in a wall. And then, of course, lastly, is going to be your thermal control barrier. And in Joe's assumption of all of this, it's best to insulate from the outside, not between the stud cavities. How many houses have you seen built today that have insulation on the outside? None.
East. Yeah, east.
Yeah, but there's a problem with that.
Well, I know that. You're asking.
I'll go to this in a minute, but I get your point. All right. Cladding system. So we have to have a cladding system in order to protect it from rain, heat, ultraviolet. You have to protect those control layers, always. But also in addition to that, you really need to have a water control or a back ventilation of your cladding system. How many back ventilation systems have you seen put up on hardy plank? Doesn't happen. The only back ventilation systems I've seen are brick, stone. A lot of times they're not being put up correctly either. They're using too much mortar. Some of that mortar is actually laying right on the control layers. And where's your back ventilation happen?
Are you saying that's a recommendation? I mean, I know it's not in the hardy or the cement.
It's not.
Fiberboard siding manufacturing specification. It's certainly not in our code.
No, it's not. This is not a code issue, but there's a reason for this. What would happen if water were to get behind the cladding system and sandwich itself between the backside of the cladding system and your control layers? It stays there. It doesn't leave. You could have potential water intrusion issues from it. It really needs to be dried out. Let me ask you this. By caulking your cladding systems, whether it be brick or hardy plank, does that prevent air infiltration? Nope. You see all this caulking features on exterior walls, you go, oh yeah, that looks nice. Well, it's only there for aesthetics. It has nothing to do with controlling air movement at all. If somebody thinks they're going, well, I'm going to caulk this hose bib right around here, that way I won't get air infiltration. You're at a different plane from where you're placing your caulk as to where the air barrier is and the water barrier is. Honestly, for me, I wouldn't caulk anything on hardy plank, except for maybe around the corner trims.
They took it out of the channel.
Well, Hardy Plank says you shouldn't caulk. I talked to a technical advisor out in California on an issue with one of these over 55 communities that on the butt end joints, you're supposed to use a flash in between the joints. Well, the first house I looked at in this subdivision on a pre-drywall, they were putting it up without those flashes. And they said, well, the builder says, well, I had a technical advisor from Hardy Plank come in and they're telling me I don't need to do that. Oh, really? It's the first time I've ever heard of that. So, not being convinced about all of that, I had to call out there and they said, well, who was their technical advisor? I want to talk to them. The corner joints, they're telling, now they also tell us if you want to use caulk, you have to back up the edge of the on the trim, on the corner trim, you need to back up the edge of the lap at least 1/8 of an inch so you can have a fillet joint for your caulk. So your caulk can actually beat into the joint, and then you can seal it up that way. But it still does not stop air movement. And you never caulk up on top or the bottom. Ever. There's no reason to do that. Now in the stucco industry, when I was certified through the driving, as a driving inspector during the class actions that were going on in the early 2000s, they were telling us you have to caulk the freeze board. I was convinced at that time you should, but after listening to this, that's an absolute wrong thing to do. And then seal up the bottoms. Well, you've just created an end dam for any water that gets into that wall. And mainly it's through the windows. So I've had to rethink my processes when I'm doing, and I don't do a whole lot of stuccos anymore. Honestly, I don't like getting up and down on ladders. I've fallen once too many. Yes, sir.
About a water-resistant barrier at windows and doors. You should put pan flash, I mean, the way I read the code is you should put pan flash in windows and doors. We never see it in the field, or once in a blue moon. Evidently there's an out if the builder nails off every hole in the mounting flange on a window or something like that. What is the exact interpretation of that? Because we're never going to see anything other than a water-resistant barrier. I mean, never, but I rarely, if ever, see pan flashing on door and window opening. Is that, what does the code say about that?
You really need to flash the window openings, because your windows, let me back and say this. There's windows that don't leak, every window leaks, number one. There's windows that haven't leaked, and there's windows that are leaking.
Well, the 15% are going to leak. We just don't know which 15%.
Correct, and eventually they will leak. So you have to be able to devise a system that, if it does leak, it runs the water outward, not inward.
So why are we not seeing pan flashing on windows and doors?
Well, they're doing it now, but they're doing what's called a flex seal. It's a big tape that's fashioned around being able to stick it to the sill, wrap it down the front, and then turn it and wrap it up the sides, at least 4 inches. It has to go up 4 inches.
Has anybody ever seen that?
Yeah. I don't see it.
I never see it.
I'm sorry? Well, pre-drywall we're starting to do, and I'll show you some photos here of a couple of builders that I've looked at properties on. One in particular over at in Sandy Springs that I thought was one of the better ones. It wasn't perfect again, but and I'll show you some of that detail work too. All right. Okay, so this is what's called the control layer, or the control boundary. And Joe Stevert calls this the perfect wall. And the reason being, this wall can work anywhere in the world. Oh. Lost my battery. Sorry. Imagine this wall down in Miami. Which way does the vapor run? Inside out or outside in? Repeat question. Outside in. Well, what happens when, again, getting back to the phasing of moisture as it turns from a vapor to condensate to liquid water? You have a vapor push from the outside of the building on this wall in Miami that goes in, hits the thermal barrier, and it hits the control layer, but the control layer has a temperature differential that doesn't bring it down to the dew point, because you also have insulation between the stud caps. You know, the easiest way to avert condensation is to change the temperature of the boundary. If you move the boundary up in temperature, you're moving it beyond the dew point. So where does the moisture go? It becomes benign at that point because there's nothing that is going to attach to it. It moves to someplace else until it finds a cold surface. All right, let's put this wall up in Montreal. Which way does the vapor transfer go? From inside out. As soon as it goes through the gypsum and then onto the control layers, the insulation that's on this outside wall has brought the temperature up of the control layers to closer to the interior temperature, and there's no condensation at that point. It doesn't reach dew point. And that's pretty much how it's done up north. These are walls that are being constructed now in Canada.
What is that insulation material they recommend put on outside?
Anything, sheet goods, foam, mineral wool is my preference. Because we don't have the issues with, they don't have the issues up there with termites, but we do. You don't want to, and if it gets wet, it's so what? It'll dry out, especially if you have a back ventilation pipe. You know, have you ever, let me ask you this. How many of you have ever pulled a mirror off an exterior wall and seen mold behind it? It's because the mirror wasn't back ventilated. When you put mirrors or pictures that have glass in them up against an exterior wall, you need to back ventilate those. You need to push them away from the wall. Because otherwise, any vapor diffusion that happens in between those two layers is going to condensate because you, in essence, created a moisture plane. Same with certain types of cabinetry. Because now we're making cabinetry out of composites. And they don't breathe, especially when you shrink wrap them and you paint them. You really need to make sure that your barriers are not real barriers, but they diffuse water. And anything that has a low perm rating is not going to diffuse water. 6 mil poly. How many of you ever seen 6 mil poly wrapped on basement walls? That's horrible. You never wrap basement walls in poly, and you never use paper-based batting insulation in basements to insulate walls.
About the knee walls.
Knee walls in basements?
In the attics.
Oh, in attics, no.
You leave the paper base in
Well, you're not supposed to leave it exposed anyway. Fire hazard. So, all right. I think we kind of know of this portion of it. Let me go over to another concept on building a wall. This will only work if you connect the control layers. All of the control layers, the control layers in your walls, the control layers of your roof, the control layers of your foundation. So in essence, The water control layer of your walls need to be connected to the control layer of your roof, to the control layer of your foundation. The air control layer to the air control layer to the air control layer, the vapor control layer to the vapor control layer to the vapor control layer. The thermal control layer to the thermal control layer to the thermal control layer. This can only work that way. So when we get this built, then what happens? Oh, by the way, we can design this pretty much any way we want. We can say, okay, well, I'm going to change the roof boundary instead of insulating the attic floor. We're going to go ahead and spray foam the attic. And this was a problem for some of the foam guys early on. I don't see much of this problem anymore, where they didn't connect the thermal boundary of the foam to the thermal boundary of the walls. And it created problems because in essence they didn't really seal the attic off well enough to where it now becomes encapsulated. I've seen some projects where they never blew away or removed the loose fill material and they spray foam right on top of the blown insulation. What sense does that make? If you want to really truly seal off an attic, it has to be done thoroughly. Oh, by the way, for those of you who are doing blower door and duct leakage testing, whenever you do this, if you have an attic space that's been encapsulated, that has to be included in the cubic foot displacement of your living space because it now becomes semi-conditioned. So when any time you look at a document, you say, well, so many square feet, but they have it calculated out as so many cubic feet. In your mind, you start doing the math, you think, wait a minute, this doesn't include this attic space that's been encapsulated. How can that be? So, all right, and then the other thing is that if you're going to retrofit a house that has loose fill or batting insulation on the attic floor, and you encapsulate it, do you really need the thermal barrier on the floor? In my calculations, when I do manual J's on a spray foam roof line, it ignores the input icon for attic floor insulation. It doesn't consider it. So it's removed. So obviously you don't need the other control barriers as well because we have the roof. So therefore we have a sealed off building in its entirety. All right.
Sandy?
Yes.
On that. Sometimes we see where someone's come in 15 years after the house was built, tried to spray from the attic. Would you be worried if they still left all the loose fill fiberglass on the ceiling, tried to seal it up? Now you got essentially a non-conditioned space up there.
Correct.
So you either need to have something to new air up there or no?
Well, in my attic, it's the house I currently lived in before I moved in. I had spray foam. And I can tell you it's made a huge difference in our utilities bills. My seller told me that he disclosed a $279, I don't know how big a house is, about 3,000 square feet. $279 a month on average, and that's going through a 12-month period. My utilities bills right now, in the worst case scenario, in July and August, don't run any more than $180. And I'm averaging about 160 some odd dollars right now a month in utilities costs. And because I sealed off the attic, and I've got an ACH right now that's less than 2. Air changes an hour.
So do we have to worry about the attic being semi-conditioned or has the insulation?
Well, here's the thing. Think about the older homes that were very leaky. And somebody here brought up earlier the issue of, the houses, the humidity levels in the wintertime are just terrible. Well, why is that? You ever think about this? It's because you're bringing in cold air that triggers the heating system to dry the air, and then now the air is now dried down to less than 10%. And it's running more and more all night because the houses are leaking. When it's sitting in a state of this type of construction, you're not running the systems that often. And imagine this, which is heavier, dry air or wet air? Wet air. And where is that going to go? So does the attic get condensed? I can go up in my attic when it's 95 degrees outside, and I'll get temperatures up there that measure less than 85 degrees. Or, reversely, I can go in that attic when it's 20 degrees outside, and it's like 68 degrees in the attic. Now, there's no air movement in there, but from the standpoint of what you've done on a situation like this, you've maximized that building envelope design in such a way where no airflow is going in and out, and now your systems are operating just as needed. I can tell you right now, when it's down close to freezing, my thermostat doesn't kick on all night. And when I get up in the morning, it's 68 degrees in the house. So, but the problem remains in a situation like this, what do you do with the moisture? And it's not a net, energy efficiency has never been and never will be a net sum game. You still have consequences. You've got to manage the moisture levels in these houses. And that's the key.
If you're heating gas furnace in the attic, you might be concerned about combustion fluid there, and all that kind of stuff.
Well, you can't, on the rule, I think if you digest down through the ICC documents, having an 80% furnace in an attic is illegal in a situation like this. You're required to make a combustion closet of some sort. Something that takes that portion of the equipment outside the building envelope, which means that you've got to bring in fresh air, or you've got to bring in a high-low vent, or you've got to bring in something to manage the displacement of air that equipment consumes.
So your house, the furnace is not in that?
No, it's in the basement, but it's a 95% AFUE system. It's got its closed combustion.
So you move chairs are always in the basement?
Well, I grew up in the Washington, D.C. area, in Baltimore, and ran that whole gamut of that area there. That's my old stomping grounds. I didn't see, the first time I've ever seen equipment in attics is when I moved here. It doesn't happen up there. They're either in basements or inside living spaces or never in garages. This is what we do here, so we have to deal with it. Yes, sir.
Growing up in New York, I agree with that, but wasn't that because you insulated the ductwork so they ran between warm rooms?
Insulation for what zones, what areas? Yeah.
So in today's construction up in the Northeast, do they insulate ductwork and put equipment in the attic?
In encapsulation, you can do that. But you cannot run open combustion appliances in attics because of the confined space issues that you have with combustion safety. You can run a heat pump up there, you can run closed combustion, 95% AFUE, where you have twin pipes, one for input, one for output, can be done. And I'll show you a picture of one that I did, a blower door test in Canton, that this guy put an open combustion system in a fully encapsulated attic. Talk about retrofit, like doing it after the fact.
Yeah, doing installation after the fact.
Yeah.
The equipment, installation.
I wouldn't advise it. I wouldn't advise configuring an attic with an open combustion furnace like this.
I'm saying, he did it, that's a mistake that he made. He should have, when the house was being built, wanted to insulate like that.
Sure.
But the fact that he made an error, can he now bring in a high-low combustion air, compensate for that gas price up there?
Yeah, you can, but then can you classify that as a sealed attic? You can't. You just lost all your ability to keep the air in up there that you were designing that attic to do. So you're in a, it's a catch-22. It's like, okay, do you want us, you have a lot of these foam guys that are out there, I know a few good ones too, actually, that do this right, and they will not foam an attic. The responsible ones won't foam an attic with an 8% furnace in the attic. They got to do something with this. Heat pump, high efficiency, whatever. So.
Sandy, is that a closed cell foam or an open cell foam?
In our climate for doing attic encapsulation,
Yeah.
I would highly recommend open cell. And for sheer reason is that it breathes. It has a higher perm rating than closed cell. Now, closed cell, mind you, has a higher R value per inch. It has somewhere between nominal around 7 per inch. Open cell is about 3 nominal. So you have to spray more of the product to achieve that at least 19 R19 factor on a sealed attic, whereas by doing a closed cell, you can do a flash coat and a second coat after that, and you're almost there. You've got one more coat after that, and then you're better than R19.
What do you do with roof leaks in that area?
That's the nature of the problem that I see is on closed cell, you'll never be able to find them. On open cell, you can because it'll allow the water to come through, but it's very, very difficult to detect. Unless you have to look down on the floors and areas of, the scope of your inspection work has to be when you go into a sealed attic like this. Yeah, you can look at the foam and all, but that's not going to tell you anything. You look down on the floor and see if you see any markings, any precipitant or droplets or indications that you've got leakage in the air, and then you can go ahead and just kind of put your finger up in the foam and, with open cell foam, you can basically stick your fingers in it and see if it's wet. If there's been a rainy condition here just recently, you'll be able to find that. If not, the only thing you can say in your inspection report is potential leak. You need to have a roofer come in and look at it. That's as far as you can go with it. Now, to the extent of it, who knows? This is where an exterior examination is extremely important. You need to understand the age of the shingles. Is the roof at its end of life? Or do we have any impact damage, hail, tree branches, woodpecker holes on chimneys? All of that has to come into play. So in a cold weather climate, it is recommended that you use a closed cell product. But a lot of the cold weather climate roofs are back ventilated. And that's a reason for that is because of the ice damming issues they have up in the north. But they get a better yield out of that out of closed cell, and you can spray 3 inches of that material and get your R19, and sometimes they'll put 4 and 5 inches of closed cell on the underside of this roof deck. But the difference being is that, like I say, we don't back ventilate roofs down here. That's just, I haven't seen it. But in the north where they do it there, that prevents the ice damming issues at the edge of the roofs. All right, getting to the walls. Again, like I said, all right, so we have this enclosure. Everything looks good. We have everything connected. Now what we're going to do is punch holes in the walls. Windows. Utilities. So, getting away from the perfect wall,
we're moving our insulation, and most of the time, and always now that I'm seeing on the new construction is our insulation is between the wall cavities. Well, that's okay, but how do you install windows? Well, as I was saying before, installation of windows has not been uniform in the time that I've been inspecting houses. You see all different kinds of processes and procedures and all. And honestly, I haven't seen a procedure yet that's perfect, that makes sense. So the concerns that I have are sealing the windows off from water and from air. And where is that done? That's done at the tops and the sides and the bottom. In particular, the bottoms or the sills of the window, you want to have a window that not only air seals, but also continues on with the water and air barriers up to a point where it you know, obviously the glass is your water barrier and your air barrier. So, but in essence, it's these locations right here that are ripe for defects. One of the reasons that I would also recommend running your this plane of your control barriers up the inside of the windows, as I said, windows leak. So if they leak, they come down here and they're carried out with the water control barrier out to the outside of the wall. So no harm is done to the interiors of the structure. Now, I've got, my wife calls me a YouTube junkie, because you can pretty much find anything on YouTube. If you want to, hey, I want to replace the engine in my car, you can go in and find a 20 or 30-minute video on how to replace an engine in the car. Well, these two videos are ones I pulled up, and I've looked at a number of them on window replacements. And these two are closer in proximity to my definition of a well-sealed window. Now, the top one is about 23 minutes long, but you can rifle through the very beginning of it, maybe 10, 12, 13 minutes of it. And the back end of that video is going to conclude itself with what I consider to be a fairly good install, but it's not perfect. And if any of you see these and want to talk to me about it later on, I'll talk to you about it. I won't get into it right now. All right. This is, again, all these pictures I'm showing you I've taken within the last year. As you can see, there is a water control barrier below the lower windows, but I don't see anything like that at the upper windows. Typically, that's installed when the window's installed. So now what are they going to do? They're going to go ahead and chink it in place and hopefully that'll work. You make the builder pull the window and reinstall it again? That ain't going to happen either. Now, and then the sealants part of it, as you kind of look closer to some things, you can see all the wrinkles and tape. You know, the tape, when you put this tape on, you're supposed to roll it. It's supposed to be rolled until you remove all those air gaps under the tape. Those are air leak sites. Here's another one. How many holes do you think this vapor wrap's going to have in it after the cladding system goes up? Have y'all seen this?
Sort of.
And even some subtle things like this. I mean, you don't have the water barrier at the bottom end, but you've got to open this bottom end up. The bottom of this has to be opened up, and then you put your flashing down underneath it. You skirt the flashing down, then you put your tape over top of it. This was, they're in this particular process, I think this house, they had already started putting hardy plank up. same. Wrinkled tape, air gaps, incomplete taping processes. Right here, this should have been skirted down lower. Oh, yeah. Still frustrated over it. Another one, what's the chance that site there is gonna leak? All those wrinkles up in there, the top part of it hasn't been taped. Again, all these houses, they were in the process of putting hardy plank up and stonework. This is a house I looked at over in Sandy Springs. This was one of the ones that I thought was in pretty good shape. I was real pleased with what I saw of it. The flashings and everything. You can see how the joints were on the rain skirt, and then of course the tapes on doing the air barrier. And again, like I said, this material that's on the outside surface acts as a three function component. It's a rain barrier, it's an air barrier, it's a vapor barrier. So continuity is really important on this, but as you look through underneath this cantilever, you think, well, how the heck are you going to seal that? An air barrier, that is. To me, that's a more important portion of the control layer than that. Are they going to tape it off? Pre-drywall ready. Holes in the, now you can attest to this too. I'm going to drill a hole after they put the vapor barrier. I'm going to drill a hole and run this gas pipeline or this hose bib. Who's responsible for sealing it up? I know all of you have seen these zip systems. They're pretty nice if they're installed correctly. Again, you see these corners where they haven't been taped. And then of course some defects along the way where the tape's wrinkled. Flashing skirt under the windows. And of course, this is a house that's going up next to mine right now. I was kind of being a little nosy neighbor, and just to see how they were putting things up. Vapor barrier. You can see where the HVAC lines have come out. And this is what it looks like right now. Think that's sealed up? This is a track built house. Or what I would classify as a disposable house. Same house I'm doing some litigation work for a client, the one that had that dehumidifier. The consequences, and this is one of the other findings I had when I ran thermal scans on. This was done back in January. End of January was pretty cold. We had some days where it was down in the 20s. And I went to the house early in the morning and I took these scans of the house, and I've got a number of them. This is just one of many, where this type of joint, especially in the cantilever, wasn't sealed up properly. Again, getting back to all the information that we have that's available, public information. This is information you can download from the DCA's website. Why wasn't it done this way? So, if you have situations like this where you're doing any kind of examination of the existing dwelling, you can point it out, but what's going to be done about it in a cost-effective way, how are you going to fix that? As I said, we have a lot of information that's available out there. I'm just kind of amazed at a lot of the trades and contractors out there aren't utilizing some of this information to guide them on doing this. Maybe that's another point for having a school that kind of brings in some of this building community to kind of let them see some of this if they're into it. Blower door testing. If we don't have the air leakage issues under control, we're going to fail a blower door test. Then what? Everything has been installed. What's the builder to do? Buy the numbers? Any of you seen that? I was asked to, hey, I'll give you $300 if you write me a passing grade.
You have your recorder on?
I told him, nope. I like sleeping at night. I don't like waking up in the middle of the night thinking, why did I do that? Let me go over the little other technical nature of the blower door test. What we're doing on this, for those of you who don't do it, I know we've got a few in here that have done them and do them on a routine basis. I've done, like I say, hundreds of these. And I can tell you that when, in my first appearance at a house, I can almost tell you what my numbers are going to look like. But you can't defeat this. When you stick a blower door fan on the house and you're taking the house into negative pressure, the what's being measured is pressure, but it's also being converted to cubic feet per minute. So it's measuring how many cubic feet displacement there is on the house at a given pressure. And typically it's around 50 Pascal. 50 Pascal is about a ½ inch of water column. But it measured in such a way where it says, okay, the cubic foot displacement of a house is leaving the house so many times in one given hour. That's what ACH stands for, air changes per hour. The maximum today's standard is 7. Next year, there's going to be 5. Most of the traditionally insulated houses that I do, fiberglass bats and blown insulation, I'm looking at results from probably in the upper 4s to about 6. Air changes an hour. On a an all foam built house, I'm looking at from 2.5 to 3.5 air changes an hour. You can attest to that, right? That's one thing to look for on the statement on the energy certificate when you're looking at it. Is this a traditionally built house or is this a spray foam? Is it a high performance house? Spray foam. And then look at the numbers. Yep, I think that matches up pretty good. I can see that. Again, like I say, all of these gauges, everything that I have to keep these gauges calibrated once a year. And they're certified. So if I were ever to get called in the court of law and say, well, how did you do it? And what type of equipment did you use? I have to show my calibration certificates. Again, you just cannot fool this system the way it is. If you're depressurizing a house and you give me the right configuration of the house, the accurate cubic feet displacement, I'm going to calculate as close to that number as it can get. And I'll stake my life on it. All right, let's move on to thermal boundaries. I think the ICC, or in particular the IRC, really obsesses over this because it's an easy thing to quantify. There's a lot of visual, there's information from manufacturers that they deal with, and all of that. And we see an array, or most of the stuff is being used today, but there's a gravity towards fiberglass insulation because it's cheap. You can blow an R30 bed on an attic floor for 40 cents a foot. But if you're going to encapsulate it, you're looking at $1.60 to 80 cents a foot. So the market really, right now, currently bears the traditional methods of using fiberglass insulation, bats and loose fill, but in the way of what's going to happen next year when we tighten the building envelope, is that going to be enough to air seal the house and make it air sealed and thermally adequate? I don't know. So ResNet is another community out there that does, the HERS folks are affiliated with it. And they have a they qualified how insulation is installed, and, you know, they have three classifications now. One is the best, 2 is not so great, and 3 is pretty poor. And the chart up here actually goes through and says, well, if we have, as an example, a grade 3, where there's 3 inches of insulation, and we go down to that point where it's a grade 3, we're going from R8 to R1.5. Inspectors, jurisdiction inspectors won't care, it's insulated. End story. But to the homeowner, in the long run, they may care. And that's unfortunate because we see a lot of this every day. And the pre-drywall inspection doesn't give us a look at a lot of the insulation barriers unless you go in post-insulation before the sheetrock is up. By the way, no jurisdiction inspectors in here, right? Any?
You can talk about it.
I'm sorry, I didn't mean to ignore you. Are the face inspections, do they include post-installation?
We do the inspections after we put it, yeah.
After insulation is installed before sheetrock?
Yeah.
Okay.
All right. Question. Yes. You get spray foam insulation throughout the house, you have to check it for duct leakage, or you care about that?
No. If you have so long as all of the equipment is inside the building envelope, and again, redefining the building envelope includes, as an example, the attic, or a crawl space. If you encapsulate a crawl space, which is foaming the walls and sealing up the rims, it's not necessary. Well, it's not, let me quantify that. It is necessary, but it's not required. It's necessary if you're doing a manual deed, because you have to quantify what your duct leakage rate is, because you're having to build that into the design.
Right. But I'm talking on the sheet that you put on there.
I'm sorry?
But on the energy sheet you put on the electrical panel, you don't have to include this. You yourself, the floor work, does not include. Look at the duct.
No, not necessary. What you're trying to do when I do blower doors for builders, or do this DET testing for builders, is just give them what they need in order to get their CO. Now, the rest of the information that goes on there is their responsibility. They need to either give it to me so I can impose it on the sheet, or they need to put it on the sheet and then provide it to the jurisdiction. But if the duct leakage test is not required, I don't do it. It's not unless I'm asked. You know, hey, I know and I haven't had any builder ask me to do it. To be honest with you. So, looking at the requirement, okay. Going back to what the grades look like, how would you grade this wall? 1, 2, or 3?
1, 3.
They didn't cut, what the installer really needed to do in this case, because once you compress this, you compromise the R value. This R value is only as good according to the manufacturer as to how it came off the roll when you unfluffed it. But if you compress it, you're basically, you compress a 3.5-inch batt down to 2 inches, you're going to get an R6 out of it. So, and what's left over here, obviously this is the wall gap that I looked at too, and they didn't have the air seal, but that's beside the point.
Is that paperless?
Excuse me?
Is that paperless? No paper.
No paper. No paper. Getting back to paper, don't use paper-based insulation.
You see it all the time.
You see it all the time. How about this? What grade is this one? This is a floor, above a garage. 1, 2, or 3? 3.
How do you fix it? What can you do?
Well, it's tedious work. The guys that do it and do it well are well paid. What the installer should be doing is cutting away, instead of lining it up on this thing, cutting away so it terminates right at the boot. And then going ahead and cutting slices of the insulation and feeding it into the gaps and fluffing it out. And then following that duct chase, or the ducts itself through the floor joist, out to where the ducts are no longer there and come back to full back. That would be the proper way to do it. This way, you're almost guaranteed your hog value. All right, let's move on here. What's this? That's in an attic, believe it or not. They didn't have anything blocked, and it was underneath the jet tub, the master. How about this? Above a garage. 3 again. How about this? Living space above, I think it was the main floor, and up. This part of it was a garage. No blocking, compressed insulation. 3 again. See, a lot of this has to be built into the load calculations. You know, if I'm running a load calc on a house and I go in and inspect it and I see something like this, I mark it down as an R whatever, 2, 3, 5, and it calculates for that. Because I have to understand that if the builder's going to leave this like that, this is the end result of the building envelope. In order to give you an accurate, calculation.
The house is built 10 years ago, you see it all the time.
Oh, my God, yeah.
You can look at it, or you can see the insulation on the garage ceiling.
Oh, and you got people, oh, my closet, my master bathroom is so hot or so cold or whatever, it's like, well, here's the reason. I can fix that. I know how to fix that. And I never got enjoyment out of people suffering, but I do get enjoyment out of helping people. And I think from the standpoint of doing these energy assessments, it kind of opened my eyes to a lot of things like this. How do you fix these things? This is a roof, this is a floor cavity. And Jason put on condition space. Again, this is a free as well. This is it's not bad. It's a nice floor. You've got ductwork raised above the insulation. Garage space, living space. What's wrong with that? No end dams. Should have run an end dam for this material, this being the partition wall between the garage and the living space, should have run it up 12 inches at least. So none of this insulation would have fallen down over the garage ceiling. That's a code violation. How about this? Ductwork laying in the attic really goes to 2 code violations. Duct support, and you no longer have R30 in that section of ceiling. Let me show you how important that is. One of my assessments, actually I've done this many times, but this is an example of one that I do. And they run the what if scenarios. What if, this roof line for the attic space had very little insulation. So I said, okay, Mr. Homeowner, if we were to insulate the floor at R30, but do nothing with this access panel, this was an 80s built house, 90s built house. If we don't insulate this and air seal it, number one, we have about 5% of the floor space that's non-insulated. When we do a calculation on the average assembly thermal barrier, we're looking at this and we're seeing it's dropping the R value, the average R value by 10%. So, again, Mr. Homeowner, if you're planning to do this, you need to take care of this portion of it too. Another thing that I also do on load calculations, this was done in West Cobb, that was back in the earlier days too. When we're doing load calcs, and again, like I say, the windows are the most inefficient portion of the house that you can put up. You lose about, on average, about 5% of your energy through windows. And it's not because they leak, it's because they're thermally inefficient. Thermal paint glass typically, back then, had an average of R2 had an R2 value. So if you imagine a wall assembly that has an R13 back, and you do the same formula by calculating what the average space is, and again, this wall had some other issues too, I'll discuss it here in a second. You look at the average R value on an assembly like a wall that's configured in this dimension, you're coming down to an R value on that wall of R5.2 seconds. That has to be logged into a load calculation. This is why a lot in the community don't want to do this, because it just takes time and it costs money. None of this is done. Now, when I ran the load calc on this building, because he was complaining that he was too cold in the winter and too hot in the summer, the reason why his equipment was undersized for the structure that he was trying to serve. That's sure reason. Now, this one here, if you look at the signatures above this main floor window, you'll see a little bit of signature, heat signature, where there's heat dissemination from above. And the question in anybody's mind, when you see that, you think, well, is this from air leakage or is this from insulation? Don't know, not unless you do an autopsy on that wall. You go ahead and peel the sheetrock down, you can see, well, there could be insulation that's like a grade 3, or you can see that there's a hole someplace in that wall where it's causing airflow to come in through it. One or the other is happening, don't know. Yes, sir?
Okay, let's assume that they did a perfect job. Okay? The thing that I have come to realize is it's all about glazing. But that's the primary cooling load on homes. So if you're going to take a wall and make a giant bow window that's 70% of the surface area, that is the load calculation issue. Particularly with modern homes where they have these massive panes of glass. I mean, when I look at that, I just say, hey, that window's a ton of AC.
That's right.
I mean, is it, in your profession, would you agree that thermal loading through windows is like, it's just not calculated correctly?
It's your worst energy loss. And if you're not going to do a load count on a building, it's almost like, this is what I need.
What we have is between 8 and 15% as far as the code requiring a separate calculation. Mm-hmm. And I think when you look at a lot of suburban houses with those big bow windows and stuff, that's well above 15% of the square footage of
well, those areas of the house are energy farms. I mean, large windows, cutouts, cantilever floors, they're all exposures that you've got to compensate for on the load count. And not only that, but distribution of air. Once you get your systems selected and everything, then is where it comes to mind, where do you apply the supply air in order to condition that load? And how much of it do you apply?
How many ducts do you put in?
Right. And where do you put them? So, all right. How much of the advanced training do you all see in new houses? Starting to see a lot of it now. California corners, that's a good one. But how about this? You see, it's still, we've always seen this up until this point, but how much of this are you continuing to see in this? How do you insulate between those cavities once the sheeting materials are put out? Again, getting back to the same house that I'm doing litigation work on, you see the signature coming up right here? Right through the center dot? That's a partition wall. Bedroom, bathroom. No advanced framing techniques like this. We're at the end of the building segment of this presentation. I'm getting ready to move toward the HVAC design. Do we need to take a break between right now? Or? Okay, all right, we're going to rifle through. We're getting ready to go into the meat and potatoes of all this. So, bear with me. What do you see wrong with this picture? 80% furnace and
80% furnace.
And a foam attic. This was the one I was telling somebody about earlier about a blower door test I did. Because I always, again, do a once through on the house to make sure everything is closed up and latching and all of that. And when I went into the attic, I saw this. Oh God, I got to take a picture of this. By the way, the results on this was 2.2 air changes an hour. You know, fortunately,
Why can't you calculate the attic volume? Put some grills on the
it's commingling. It's commingling. You're not allowed to do that.
It's conditioned space.
I know that, but I think the code is now reading that you're supposed to pull the air in on combustion from the outside now, on these high-performance houses. I think somewhere in the IRC that I've read, and I would have to look it up, that when you're looking at confined space provisions, you know, usually type construction, that they're starting to gravitate. I think the codes are going to change to where they're going to be a lot more specific about this, but I would never approve this. If I was a jurisdiction inspection, I'd say, nope. Now, fortunately, these systems have they're reduced fan driven. They have a pressure sensor in them that if the pressure inside that inducer housing goes down to near zero, it shuts the whole system down. But yet, it's taking, to a slight degree, that environment into slightly negative pressure with respect to outside. So that's still not a good thing. But it's not, for me, now if you put a naturally drafted water heater in this confined space, I'd say you've got a real problem. Serious problem. Or anywhere in this house, you would have a serious problem. So, how about this ductwork? Ever see that? All the time. Oh man, I can't tell you how many times I see this. And when you go back to, in certain cases, when you go back to the installers, well, this is how we've been doing it all the time. This is, I don't see any problem with it. Well, the code says you shall install pre-manufactured ductwork according to manufacturer's instructions. The manufacturer of this ductwork doesn't say to install it like this. It says you cannot restrict air movement. How about this? I can't get it around that laminated beam. I need to just twist it and turn it.
Well, the DCA on the website has a picture that shows you do that also.
Yeah, I mean, it's all public information. I just pick up the books and look at them.
These guys don't get
Well, here's the grab on all of this. The builder's trying to get it done the cheapest way possible. He's going to go around and to all these installers, all these HVAC companies, say, I need you to install the system, I need you to give me a quote. And he'll go to the next one, I need you to give me a quote. He's going to pull. Doesn't matter if it's done right or wrong. It's done. It's Move on to the next project. And that's kind of a sorry state of affair, to be honest with you. Duct connections. I'm sure you've seen this type of work. And of course, again, getting back to the compressed duct issues and how everything looks up in tight spaces. I keep myself into looking at some other things on ductwork. How many of you have seen duct splicing done like this? This is the duct splice. The manufacturer and SMACNA and the ACCA says you're supposed to use sheet metal collars between these duct connections. You're not allowed to sleeve one end of a flex duct into another and tape it and call it a day. That's illegal, according to the codes and the manufacturer's installation procedures. And not only that, you're supposed to tape, mastic, and strap it. Now, how do you find these? Yes, sir.
When you look on the outside, you know, and this side on the outside, you see a band tape on it.
Not always. It is a good point. If you can reach them, if you can access them, I squeeze the ducts. If I don't feel anything that's rigid inside there, it's not connected. Yeah, sometimes I have to pull a stepladder out and get to them. You know, you do what you can, but if you find one, chances are there are more. Because to be honest with you, the installers, they want to get it done right away. They don't want to go back on the truck to pull a sleeve or go back to a supplier and get a connector and do all of this. It takes time out of their day. So they connect it just like this. But not always will you see, and I've come to know this, but if you see just tape wrapped around a section of duct, you automatically should be suspicious. If you can reach it, squeeze on it. If it squeezes like a piece of ductwork, it's a connection. And it's done wrong. And you call it out. In my reporting system, I have all these templates built. Noted a number of, or many, or whatever, noted a improper duct connection. Recommend having the HVAC contractor come back and do an overall evaluation of every duct connection. That's about all you can do. Correct whatever's needed to be corrected according to these standards. And you gotta leave it go at that, and you have to trust that they're gonna do it. You hope they do. Because these are eventual failures. These systems are going to fail. How many times have you gone into a 20, 30-year-old house and see a flex duct connection just drop down to the attic floor, disconnected? More times than I care to think. And this is the way these connections are made are going to prevent that or reduce the risk of it happening. Things like this. If I automatically see the insulation on a duct, it's a defect. That's it. And light squeezing on two ducts. See that sometimes too. Lakeside. Think that duct's not twisted at the end? I had to stop for a minute and look at it and thought, man, I wonder how much restriction is in that ductwork. I took my camera up and I took a picture of the inside. That's the inside of that. I just put the camera up and I snapped a shot of it, and that's what I took. Think that duct is symmetrical? How much airflow is going to come through that duct? What's that going to do to the static pressure if that was a return vent? What's that going to do to the static pressure of the operation of the system? Lessen the life expectancy of the equipment and return to that. It's more of the same. It's more of the same. Yeah, this is. Now, getting to the point of duct leakage testing. I always tell my builders, if I have to do a duct leakage test, make sure you seal the register boots to the sheetrock. Because I face seal all the register vents, and the process is very similar, and I'll go over that in a second. You've got to seal up all of the register vents. And by the way, these last two pictures was of this house I'm representing the client on. Is one of the other things I found. And when I ran the duct leakage test on this system up in the attic, which was a 5-ton air handler, there was a lot of ducts to seal up. I was up there for a couple hours setting this process up. It failed. It didn't pass. And the reason is because the builder never sealed, or the HVAC contractor never sealed it up. Now, you'll get a lot of reasons behind it. Well, I thought the sheetrock guys were supposed to seal up, or the installers were supposed to seal it up. I don't care. Seal it up. And then call me in and I'll go ahead and run the duct leakage test. In this particular case, I was just doing it, like I say, for a client. But to the point of doing this, here's another thing that's a benefit. You seal all these up, what's that going to do to your blower door test? You're just taking care of a leak site at the same time, especially from the upper floor of the building. What do you see wrong with this one? Pre-drywall test. I know the suction line and the evaporator line are not connected, but what's wrong with this tape job? Not enough mastic. You should not be able to see the tape. See a lot of that. I see systems that haven't even been mastic. All right, duct leakage testing. For your information, this is another test that's required on any system that is, any portion of which is outside the building envelope. If you have a fully encapsulated house, attic space, all of that, crawl space, whatever, and you have systems in there, it's not required. But in this case, and the other caveat to that too is that on existing construction, if you put a brand new system in, you're required to have a duct leakage test done. If you disturb any more than 50% of the ductwork, if you alter any more than 50% of the ductwork, you're required to have a duct leakage test done. If you move anything, if you replace an evaporator or an air handler, you don't have to have it. There's one other exception to it. If you don't alter anything within 5 feet of the air handler or evaporator, you don't have to have it done. If you like change a plenum and it goes out 10 feet, yes, you have to have it done. Yes, sir.
Was it changing 50% of the ducts on the floor or the entire house?
Entire house. The whole system. All right. The method behind how we do it is that we, instead of depressurizing the ducts like in a building envelope check, we pressurize the ducts. We take it up to 25 Pascal, which is an approximation, it's what an air handler produces. Again, looking at low static pressures, we want to mimic what the air handler is producing on all the joints. And it's not just the ducts we're checking everything in between the ducts as well too. Evaporator, plenums, filter rack, all of that is being checked.
Both supply and return.
Supply and return. When we set up these monitors, and you see these lines right here, I'm setting up a pressure gauge right at the fan connection and also at the supply connection. I'm hooking the fan, the blower unit, either at the air handle blower compartment, or I'm selecting some location along this return airstream so I can pressurize the entire system. Getting to the point of how it's measured, for every cubic foot of air that's pushed in, a cubic foot of air is leaving the duct system. And that's how we come up with our percentage based on area served.
You know, from a selfish standpoint, when I'm adding in the summertime, it's 120 degrees, I kind of appreciate leaking ducts like standing in front of me.
Yeah. Yeah, but what does that do to your house? If you have a supply duct leaking into that. To your point though, if you have supply duct leakage in an attic, right? You're pushing air out of the building envelope.
Right.
What does that do to your overall barometric pressure inside the house with respect to outside?
Still feels good though.
I know. Keeps the attic cooler so you can work up there, right? All right. All right. So this is a picture. You can see how my design is on fake ceiling there. I use vent caps just like some other folks in here do. And it's basically designed to cap the entire register bed. So I'm looking at everything, and that's how it's supposed to be done on a PCT or a PCO.
Do you have to take a register off?
Nope. I have, what these caps are, they have a little hook on a string, and I grab a hold of one of the vanes and pull it up and attach it to it, and then it's got gaskets around the cap, and it seals it up.
And how much does this test cost?
Depends on the size of the system. 2 ton, I can run about 75 plus site visit, 150. I can do 225 total for a single system. When you're running a 5-ton air handler, which you've got a lot more ductwork, a lot more register vents, you've got to go 150 or more because of the amount of time it takes you to seal everything. Again, setup and tear down is your laborious portion of the work. It takes me less than 10 minutes to run the test. So once I'm set up, got everything, and everything is capped off and sealed, and I know the filter rack cover's in place, because a lot of this is examining not just the ductwork seals, it's examining the air handler. Do I have a filter cover on? Do I have everything? Do I have any other things that are disconnected upstairs? Because if there's something disconnected, there's no sense in running a duct leakage test. It's going to fail.
What about a 2-story foyer that's got that way up there to fill off a register or wheel?
There was a story told earlier about that, about somebody falling off a ladder. I was younger and stupid one time and fell off a ladder about 11 years ago. Put me in the hospital for 2 days for doing just that. Because I wanted to do this right with this client. We've got to get back to safety concerns on all of this, because when I fell from 20 feet on my back. My L1 and L2 were cracked. I got a steel plate in this wrist, crushed wrist, 6 screws in here, several operating plates. Fortunately for me, somebody up there was looking after me, because I'm vertical, still vertical. And I'll be walking straight, but I'm still vertical. But you're going to find there where, and you can calculate this out. Let me tell you this. If I was smart back then and thought, okay, that's a 6-inch duct. If I run this test, I know I'm going to be leaking. How do I get around that? Well, if you don't seal it, a 6-inch duct on a flex side runs anywhere from, 50, 60, 70 CFM, something like that. You can back calculate that out on your result and say, okay, I know this was leaking. I'm anticipating this much air is going to leave this duct. I'm going to go ahead and factor that in or derate the result according to that leak set. That would have been the smart thing. But I get your point. I mean, it wasn't a pleasant time for me 11 years ago. It was.
I think about these houses have the where
Yeah. Some of them are just like, oh my God, do I have to get up on a ladder to do that? And the answer is no, you don't. Yes.
If I recall right, don't those stands, they have a screw where you can put an extension.
They're extensible. I use them.
They can hold it up there.
You can use it up, you can take it, attach it right to, in an extension pole. I have a telescopic pole that goes up 12 feet. Like you say, some of these ceilings are cathedral is 20 feet or more. And that's how, excuse me, that's how far I fell. I had a 20-foot extension ladder and it slipped out from underneath me. Yeah, it's one of those moments. It's almost here.
It's behind you.
Cold coffee, that's good. All right. Again, getting back to how we do it, the gauges and the principles behind this are pretty much the same as your blower door test. We use a set of magnet healing gauges that are very accurate. And I do what's called a multi-point curve. I do, when I'm measuring it this way, most of the measuring that's done is single point. I do a linear regression curve that actually spans from 35 pascals all the way down to 10, and I draw the line, and I look at where my y-intercept is, and that's the result. And under any circumstance along that pressure pathway, I should be able to see the same number, which that validates the answer. Now, most of your guys that are out there doing it, they do single point. I think that's going to change. Not here anytime soon, but I think it'll eventually catch up with us, and I think the demand is going to be that we get more accurate results. So I do it anyway. What do you see with this one? Plastic. Here's something else too to consider. Your standard builder's grade filter rack. Remember what I was telling you before, that it's not just the ducts we check everything in between. You think you're going to get us, in the future, when the requirement goes down to 6% leakage, you're going to get a passing score with a filter rack like that? Not going to happen. It won't. So if you see a duct leakage result on your certificates that says, I got 4% duct leakage with a filter like that, claim BS. It's not right. And you see this, even that filter rack, and this was a new construction site. The filter rack, the cover wasn't even, there's a flashlight I put in there just so you can see how much light was coming out. And this was when that filter rack cover was in the closed position. The HVAC contractors are going to start having to use weather-sealed compartments, April Air, Honeywell, anything. And I mean, they make some good products out there, and they're not that expensive. This is another one where, you see a lot of it too, where the filter rack is plastered right up against the air handler, but look at the hole. Let's see this. See this right here? You think that'll pass? And this is another pull-in drawer filter rack that just has no gaskets, no sealants or whatever, none of that stuff. Oh, it is, but it's going to go by the wayside next year. That's a picture of that same system with the filter out. The consequences of all of this also too is that you're going to increase the maintenance cost on equipment. You're going to shorten its life. If you don't seal these ducts up and put good filters in that are well sealed, it's going to cost you in the long run. All right, now we're down to the certificates. And again, this is a picture of the house. This is a picture of the load panels in this house I'm recommending my client for next month. Couldn't find it. Where is it? Nowhere to be found. Again, like it's supposed to be either fastened on or near the load panels or on or near the HVAC equipment. That's where you first look at it. We'll look for them. This one here is in the wrong place. It's on the inside cover, but that's neither there. At least they put it someplace. At least I've got some evidence that it was done. All right. You're going to find different or variations of certificates out there. It's not just, this is certified in ECA. This is a format that pretty much most jurisdictions use. There are some jurisdictions out there that have their own. Paulding County is one of them. Johns Creek is one of them. Noonan is one of them. And there's probably some others out there I haven't done yet. I have my own. I use a spreadsheet. This is derived from a spreadsheet method I put up there that does my own math for me. So I can put in, like an example on the a cubic foot displacement on the blower door, I can put that in, put the CFM on there, and it spits out a result based on the air changes per hour, and it tells me whether or not it passed or failed. I haven't had, with the exception of those counties and municipalities that I've said, I haven't had any other municipality reject this. So you're going to find others, and I'm going to show you some other sheets that are out there that I've covered. This is one. Can you all see those numbers, by the way? Yeah, I should have blown this up a little bit further. See a lot of missing information. I printed this out for my client, and I showed them what is needed. Now, I've redacted all of the information there pertaining to the identification markers, who did it, contact information. That's, I don't want to be called to the carpet because I denigrated somebody's intentions, but I want you to see what I'm seeing. I don't know if you can see this number right here. See that? It says 1,400 CFM. How do you get 1,400 CFM from the size of equipment they've got in there? 2 systems. And a minimum is a 2-ton, which is 18. We're looking at 400 cubic feet a minute per ton. The 2-ton system is 800 cubic feet a minute. How do you get 1,400 CFM on a total calculation, a load calculation for 2 systems? Again, this is telling me right here, there's two units. Minimum sizings are, and you can get I guess you could probably do 1.5 tons, but these were 2-ton systems. So that right there was a marker for me to say, wait a minute, yes again. Missing names, missing this, missing that, missing that. I mean, just. Oh, by the way, one of the things you can do for yourself, especially if you're doing pre-drywall inspections, typically these fenestration stickers are on windows. They leave some of them on maybe. Go ahead and take a picture of it, because when you come back to do the final inspection, you need to go ahead and check to see if that is the same data that's on the certificate, because that's required to be put on there as well too. And I've caught a couple of them where they weren't. Missing area served. Again, all this missing information up here. 16,711 cubic feet. And the rest of it, I mean, as far as the testing goes, I don't see anything that grabs at me. But there's a lot of information that's missing, so it leaves a lot of questions in anybody's mind as to what's real on this, what isn't. Again, more of the same, missing mechanicals, missing manual J. You know, it's like.
Well, you know, I see a lot of these got some blue painted faces, got, you know, little people on there. Is there anything that you had here to make sure they are permanent?
Meaning where you fix it?
Yeah, or I mean, like they sometimes just see a little piece of blue paint or say, you gotta realize that just move it.
Right. What I do is I provide my builders with, when I do a blower test or a duct weightage test, and I'm going to fix that to the whatever it needs to be fixed to, I give them a package envelope, one of these clear seal package envelopes that it sticks on, has, you know, peel back, stick it on, I fold it up, shove it in there, and stick it right to the part. Yeah, yeah. You see it sometimes, and yeah, that's just Unfortunately, that's not all the time. 3.6% air leakage. The only time I see a 3.6 air leakage is on an earthcraft house. This doesn't happen on a traditionally built house. So what do you do about it? You almost can't do anything about it. Not unless, you know, the client calls into question the validity of the results. But again, missing information on this. They've got a couple of things in here that, you know, are missing on the mechanicals. This is an interesting thing. You see this right up here on this one? I knew this one in particular because I did this. It says R19 cantilever floors. There were no cantilever floors in this house.
Hey Sandy, you said earlier if the builder gives you this information, you're fine with filling the form.
Sure. If he gives it to me because I have a paper trail.
I was going to say, I feel like the liability scares me. What if they give me the wrong information and a callback 6 years later, and he says, oh, I didn't fill that form?
You have to keep the documentation. If he sends me something on hard copy or electronic format, I save that. That goes into the file.
I guess it just goes back to that call that he's saying, well, he filled it out, I did it, and you have it on file, but yeah, I filled it out for him.
Right. Well, on the bottom of mine, you didn't see this. I have in there, all the information was pertaining to the building design and characteristics were provided to this DET certifier by the builder, designer.
So there's your liability waiver
Yep.
right there on, okay.
Correct. And you see a lot of this information here. Some more of the same. A lot of the stuff, and again, I'm trying to prove the point to some, oh, I didn't mean to go into the signature, so we're going to black that out. Anyway.
So the bottom line is this whole procedure is a joke.
Oh, my God.
Because shouldn't the responsible county official be making sure that this is done correctly?
Well,
I don't know.
You don't get your CO to fill this damn thing out.
well, it's filled out.
Come on,
The
Chris,
code
tell us.
says you need to fill it out. It doesn't say anything about it to be right or wrong.
Well, that's the point. It needs to be right.
Well, that's what the code said, that the quality checks on these certificates are being done, but they're not.
And I make the same way.
We as third-party inspectors can't do that.
More of the same. I can go on and on. I've got dozens of these examples, and I just want to, a lot of it is the same stuff. And I've got one more. All right. Here's two examples of two certificates I pulled on brand new construction at two different dates. Okay? I want you to take a look at something on this. Some of the data is different. And some of the data, take a look at the load calculations on these two certificates. Look at the numbers. Can you see them?
Yes, just read them to us.
Heating load, 62,600 BTUs. Heating load. 62,600 BTUs. Cooling load, 39,650 BTUs. Cooling load, 39,650 BTUs. the sensible load was split up to 35,288 BTUs. 35,288 BTUs.
These are two different
Two different houses, two different events.
So you zero out one and put it on the other.
Well, no, they're all, you look at the type set and everything is different. CFM, 1,490 CFM, 1,490 CFM. What are the chances that you're going to have two identical manual J's?
Well, you use the same contractor, pretty good.
My God. Did you say copier machine? Yeah. All right. And then, no, I made a mistake. I had one last one here. When I do load calculus, here's another point of concern. You see the 70,000 BTUs and 56,000 BTUs, 56,600 BTUs. When I do load calculus, I never, ever come up with an even number. All my numbers are set up and designed around the exact load count. In this case, like this one up here, where the heating load is 47,325. When you start seeing these numbers like this, you know that the calculation isn't done, it's not legitimate. All right. I think that concludes everything. I'll be around till lunchtime if we want to discuss, if you all want to discuss anything else pertaining to this. I've enjoyed your company, by the way.
A lot of really good information. We're going to break for lunch.